In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice? A flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played...
Oh, we're supposed to be watching the stream.
All right, gentlemen,
Sure.
we are live.
Okay. All right, I'll mute.
Thank you, sir. Yeah, so the rules of engagement are as follows. I'm going to give a brief prezi here, uninterrupted as best as possible, please. And then we will get into open Q&A about it. And then I think Mike here is joining us as well. So if you have any questions for him, and then please just remember to remain respectful at all times. All right, so here we go. So starting with the null hypothesis, we're going to be looking at mutually exclusive elevation angles confirmed by the positions of celestial bodies intersecting them at a specific time. And this is going to nullify the claims of refractions or where the star appears to be behind the mountain, etc. This is going to be explicitly showing that the elevation angle is correct because it is the physical point in which there is an intersection of the celestial body in question. So we're going to be looking at the timing specifically for this and the raw angle calculated based off of the elevation between the observer and the peak of the mountain here. So I'll go over how to calculate all this out and what the implications are here. So we have our two hypotheses here. The Earth is flat and the Earth is not flat for our null. And looking at the position of the Rocky Mountains here, we enter the latitude and longitude, and then we get the we get an initial bearing here after we get a target, but we'll talk more about that here in a second. So anyway, you need your coordinates for where you're observing, and then you need the coordinates for what you're observing, and then you can computate the distance for that from this website here, movabletype.com. And anyway, when you do all that for Pikes Peak, for example, at a distance of 50.7 kilometers, you'll get an angle of 2 degrees and 31 arc minutes for the raw calculation. So in other words, we're saying that this mountain peak right here is at a 2 degree, 31 arc minute elevation. And we're going to use a star to intersect this mountain peak at a specific time to confirm whether or not this is the actual angle or not. Because if it's not the physical angle, the star will intersect at a different time, which will correspond to a different angle. All right, so when we get into the instrument in question used to confirm the angle during the day, we have a David White 8300. But again, the confirmation during the day and measurement during the day isn't necessarily the valuable part of this. The actual confirmation of the physical obstruction based on the timing is what confirms the calculation of the angle being true, because during the day there's going to be refraction and whatnot. So this is going to change throughout, like the actual angle when you measure throughout the day is going to change. But when you get this starlight intersection, it's only going to be intersected by the physical object there. So this is why this outweighs that. So it eliminates all the refraction between you and the mountain. And you could consider that timing when you make that measurement. You could teleport from this location to the mountain, and that angle will match up for where the star was intersected at, without any further corrections. If you're on a globe, you're going to have to add an additional refraction correction to that, which we'll go over here in a second as we continue, and we'll see how that plays out. So the globe is going to exist in the form of two refraction corrections, one on the ground and one on the mountain peak, to supplement the position of the star, as they're going to tell us when we go to Stellarium to confirm the angles and timing. So anyway, here's a shot of the mountain peak there, 4,300 meters, 50.7 kilometers, and then his elevation angle to the where he's making the observation at is 2,074. And we go through and get the angle for that, and it's 2 degrees, 31 arc minutes. Now here we have the refraction stuff, which we'll skip over until we get to the relevant portion. So to give you like an orthographic side view of what we're describing here, is that based off of the timing, we're confirming that this elevation angle is the true elevation angle. And this is where this, meaning this mountain is physically here. So like throughout the day, this might fluctuate in values when you're taking measurements directly on, but when you're using the comparison of timing in the elevation angle of the star, to intersect at that point, then you're confirming the correctness of this. So that's how they're doing that. And then we're looking at 39 Aquarii, where he's showing the timing for the intersection there. And when we go over the corrections for the globe, we're going to find that the 15 arc seconds that are added at the observation point and then added when we get to the mountain peak are going to create this quote unquote true position of the star at 2 degrees and 46 arc minutes here when we go over the math. Whereas on the flat Earth, with just the raw calculation, we're just using the elevation angle in the observer in the distance to derive the angle. So it's just the raw plane trig angle. We're not adjusting for globe slant or anything like that, like we would for this correction and refraction. The only way that the globe can come close to this prediction is by refraction. So they actually measure a smaller angle. I think it comes out to 2 degrees and 2 arc minutes, I think. And then you refract up 15 arc seconds to get 219. And then when you're on the peak of this mountain, you got another 15 to come out to 246. So you have 2 separate predictions there that aren't manifested. And this was confirmed again at a different location, Blajat Peak, using the same trigonometry. So just the elevation distance to get the angle and the actual distance to the peak will give you the angle. And then the star was occluded at the at the time that was predicted by Stellarium to confirm that angle. And on a globe, angle would be 1 degree, 18 arc minutes. And then if you were to go to the peak of that, when you're adding the refraction correction to it, you get 1 degree, 36 arc minutes. So 2 different predictions there, and neither of them match up. But the flat Earth raw correction does. So when you go into Stellarium and turn refraction off, you get the raw position of the star, which I'll show you guys now. Give me 1 second. Pull up those for comparison so we could see what it looks like. This is courtesy of Shane. Link. I'll just go with link. Okay, so so for flat Earth, right, when you get the final bearing for everything, when you calculate everything out using those tools earlier, you get the direction that you're going to be facing there. Then we have the elevation angle here for 2 degrees, 31 arc minutes, and that is where the star intersects at. Now, this is without refraction on, and then when you turn refraction on, you get the globular predicted angle of 2 degrees and 46 arc minutes. But the star, right, remember, physically was occulted at 2 degrees, 31 arc minutes, falsifying this as like a tenable position to explain where the star actually is. So what this shows, the implication of this is that all this like celestial navigation and this star, like all of this data is based on flat Earth elevation angles with the stars, and then the refraction corrections, terrestrial and celestial, make up the difference in Earth curvature. So when we look at the difference between the 2 predictions here, oops, I got to bring it back the other thing. Give me 1 second. Okay, so when we look at Pike's Peak, for example, right, when we go over the example that we just looked at from Mike's PDF, the raw flat Earth prediction is 2 degrees, 31 arc seconds. Accounting for globe slant, you get you have to subtract 27 arc seconds from this. So there's going to be a 27 arc second difference. So they predict 2 degrees and 4 arc seconds. I have the rounding thing on this off a little bit. This is supposed to be 2 degrees and 4 arc seconds. But anyway, 1 second, was there something? Arc minutes. Sorry, did I say seconds? sorry. Yeah, 2 degrees and 3 arc minutes. Sorry if I said seconds. Let's see. So anyway, this is what it comes out to when you account for a globe slant, and then you add 15 arc minutes for the refraction correction. And when you go, when you add that to the peak as well, that's where you get the 46 correction. So you actually, the globe doesn't exist outside of this refraction difference right here. So the difference that's being made up here for the globe slant in refraction corrections is the globe slant. So, and then that was again shown at Blodgett Peak. So the significance of this, just to recap, it doesn't matter anything going on over here, like where the star is light bending around the mountain? Is it coming up over it? All that matters is that the timing that this was intersected at tells you the correctness of this calculated angle here. All right, so if there's any questions or comments, we can get into how to replicate this and use this. And this spreadsheet is available for anyone to do their own stuff, but to kind of walk us through how to replicate it yourself, right? What you would need to do is pick a mountain peak, pick an observer point. Then you could go to this website right here. It's a movable website. I'm gonna go here. You start with your observer point here for point 1. You enter the mountain peak here. It's going to give you a final bearing and a distance. So you save the final bearing for later because you're going to need that for Stellarium. You take your final distance, you put it in here. You look up the, you go to this website to get your altitude based on your GPS coordinates. So you can use that same lat long here to get your elevation for your observer height. And then most mountain peaks, you can just like Wikipedia them or whatever for their coordinates, and it'll have the coordinate that takes it to its maximum elevation or whatever. You can just look it up. But anyway, once you have that, you put the necessary information in here. You get the difference in altitude between the observer and the peak. You get the distance conversion here for kilometers. And then everything else will be calculated out for you for what the necessary angle would have to be. And then you could go into Stellarium, for example. So I have mine configured right now for a mountain in Alaska, the Denali Mountain. And then when I enter, I think it's like 6,100 meters or something like that, with a distance of 52 kilometers. Anyway, it all comes out to an angle of 6 degrees, 11 arc minutes. And then my final bearing was 163.55 arc minutes. So anyway, what you would do is you would come here, you would hella zoom in, and you just kind of play this out and wait for a star to pass. And when you get a star at your relevant intersection point, mine would be right here at this point. So I'm just waiting for stars to pass. When I find one that intersects here, I get the timing. And then presumably I would go to the mountain peak, or I would go to the area at this time and look at that mountain peak. And then I would see this star getting occluded at that time. And that would be one way that you could derive how to do this. And then there's a couple other ways Mike was saying how you could do this. One, if you know the star and you're watching it or whatever from your location, that would be like the easiest optimal way, but you could do it without knowing any of that. All right. So if there's any questions, comments, or anything like that, I'll open it up to the floor now.
Pick me.
Well, I think Jeremy gets first. He called it already.
All right.
All right.
Jeremy? Nope. All right. You lost your spot, bro.
Can you go to the spreadsheet page, Alan?
Oh, he said you can't VC.
Right, so on the left diagram at the top of Pike's Peak, that 231, that's your prediction from Stellarium, right? Without refraction. Cool. Is it correct? Like, do you accept it as an accurate prediction?
If the star gets occluded there, then over here, then yeah, it has to be.
I'm just asking whether Stellarium gives you an accurate prediction.
Yeah, I pulled up the pictures earlier where you can see that it does.
Okay, Stellarium is accurate. I agree, but I would include refraction, but that's not relevant right now.
It's super
relevant.
So
it
has 2 predictions on it. One's accurate for where the star physically occults a structure, confirming the elevation angle of the mountain that matches the flat Earth prediction. And the other one is a globe prediction that places it at that to not be intersected at that timing.
So as long as you're consistent saying it's accurate without refraction, all right, so from Pikes Peak, it's 231. What is the prediction without refraction from Mike's house?
What?
What?
What's the prediction from his house where he actually made the measurement?
The
Yeah,
same.
2
it's
degrees
accurate from
31
Pikes
arc
Peak.
minutes. The
The-
same
the-
exact one.
No, what's Stellarium's prediction from his house?
We're looking at it right here. The alt as 231.
31.
Yeah,
Pikes Peak.
231.
That's from Pikes Peak.
Let me jump in here. Rue is trying to trick you.
No,
So-
Trick you
I know.
by setting the
We
observer
He's
to
trying
where the
trick you.
observer
He's
actually
Yo,
trying
was.
to
hold
turn
on,
this
hold on,
back
Rue, hold on.
into a refraction.
Go ahead, Mike.
Go ahead, Dr. Mike. You got the floor.
Okay, Rue's trying to turn this back into what is observed from my house with refraction, because that's the only way he can argue with it, or what Stellarium says it should be observed from my house with their globe Earth 27 arc minute correction built in. And what he doesn't want to, what he's trying desperately to avoid dealing with, is that Pikes Peak is 2,226 meters above the elevation at my house, and it's 50.7 kilometers away, which means the calculated plane trigonometry elevation is 2 degrees 31 arc minutes. What he wants to confuse you with is he wants you to set Stellarium to the coordinates of my house, and or set Stellarium to the coordinates of my house and see what it says the angle should be. And we all know Stellarium's going to assume I'm on a globe Earth, and it's going to give the globe Earth prediction, not the plane trigonometry prediction. So be aware of that kind of sleight of hand as you're talking to Rue.
Okay, we're not off to a good start, Mike. All these accusations of being
We
the
are
devil
not off to a good
reptile.
start because, as I told you over and over again, you don't understand the principle. You want to keep changing it into your argument instead of understanding what was actually done.
Okay, I'll respond to all of your points if you like. First one is I want you guys to either say yes, Stellarium gives me an accurate prediction for wherever I am, or no, it doesn't. Right? So you are, well, Alan is saying, and I assume you're saying, that if you put the observer on Pikes Peak, that 2 degrees 31 is accurate. Is that correct?
Stellarium gives you a very, very precise globe Earth prediction, whatever coordinates you set into it.
Okay. Irrespective of whether Stellarium is a globe program or not, does it give you the correct prediction regardless of the shape of the Earth? Does it give you the correct angle?
Yes, when you have refraction
Yes.
turned off.
Okay,
That's
so
key.
without refraction, that's
Your
fine.
question
That's
is
fine.
missing an adjective. It's whether it gives you the correct apparent position, right, Rude?
Well, I think it's correct with refraction. You guys don't. That's fine. We'll as long as we're consistent, all right? So you're saying if the observer's on Pikes Peak, that angle that it predicts without refraction is correct, right? Why is it that if you stick the observer somewhere else, it's now incorrect? That seems like you're cherry picking.
What?
What?
The point you're missing and the point you consistently miss is you want to say it was my house that was occluding the star, and that's why
No.
you want Stellarium set to the location of my house. It's not my house that's occluding the star, it's Pikes
Well
Peak.
aware of that.
That's why it's only going to give you an accurate elevation from the point that actually occluded the star. And so everybody who's debating, beware of that sleight of hand there. It's, you need to know the elevation from the place that actually occluded the star, and don't let him trick you into believing because it shows a different elevation from my house. That's correct. It would be correct had it been my house that occluded the star, but it wasn't my house that occluded the star.
I gotcha. I
I'll
see what
ask the
you're saying.
question again. Regardless of any mountain, if I point the telescope, regardless of where I am and if it's being occluded or not, if I take the angle out of Stellarium and I point my telescope at that angle, will I see the star, no matter where I am? Are the predictions correct of Stellarium?
So yep.
It's a yes or a no question.
But it's not a relevant question. Yeah,
Yes, it
obviously the
is. Yes,
angle is
it
going to
is.
be different if you take it from a different position.
Right.
Why are you trying to
how about
change
we
the
set the
position?
observer
You're missing
to
the
where the
point.
observer is?
Dude, you're
How about we
missing
do
the
that? We
point
set the
that
observer to where the observer is.
you're missing the point that the star
No, I'm not.
intersecting with the mountain confirms that angle. So that
What angle
mountain
is
is actually there. The raw flat Earth angle that was calculated.
Right. Let's assume the mountain has disappeared, right? And we're just looking at the star. What angle is that? And what is Stellarium's prediction?
The same angle. It literally got occulted at that peak. That's
What angle? 231?
Without correction,
Look,
2 degrees, 31 arc minutes, bro.
Okay. So what is
It's right there.
Stellarium's prediction? What is Stellarium's prediction?
2 degrees, 31 arc minutes
No,
without
it's not.
refraction.
No, it's not. No, it's not.
Oh, you're just saying nah.
Well, I'll show you what it is.
You're literally
Let me
just saying
share
nah,
screen.
but it's like it's right there.
No, it's wrong. If you open Stellarium, let me go live. There we go. The predicted Stellarium angle from his house with no refraction is 2 degrees 6 minutes.
Note that he just said from my house.
What?
Again, missing the point that it is not my house that's occluding that star.
Right.
I understand. Let's assume the mountain has disappeared, right? And you're just looking at a star at 6:25 and 27 seconds, or whatever it was. At what angle does Stellarium predict you will see it? Ignore the mountain. The mountain has disappeared, vanished. What angle
The
will
reason you
Stellarium
can't
predict?
ignore the mountain is the method by which we are eliminating the refraction between the mountain peak and the observer.
Exactly.
Okay, you can't limit refraction. Refraction is always there.
Ruhif, we've already limited it with the mountain. You already agreed that the mountain has to physically be
physically
there
there.
to block the starlight. So,
You
so
can't
what
make the
you're
mountain
what,
disappear,
yeah,
bro.
what you're trying to do
That
is
doesn't mean
obfuscate,
that light is not curving.
buddy.
Let me change slides. Hold on. You guys think, there we go.
Doesn't
You guys
matter at
think that
all.
it has to be a straight line. Why does it have to be a straight line when we've got an atmosphere?
Dude, it's
Bro,
physically
what is
blocked
this
at that
picture?
angle. That doesn't have anything to do with it. The apparent
This is
position, as I
exactly what's happening.
covered, is irrelevant. The intersection point confirms the angle of that mountain. That is where that mountain is at. The globe prediction for the elevation angle of the mountain isn't real. It's not at that
Not real.
elevation angle. Otherwise, the star would occlude it at a different time to produce a different angle. Yes, what you're doing is completely irrelevant. You're making the conversation about something that it's stop laughing and going, you're making it about something that the conversation isn't about. You're not addressing the point at all. Here is
the point, right? Here is the point on screen now, right? The globe's prediction for the angle to Pike's Peak is 2 degrees 19 minutes. Stellarium's prediction is 2 degrees and almost 19 minutes. That's where it got occluded. And that's the angle from his house when we get a professional surveyor out there. Who wants the best?
Oh, wow.
Dude, the professional surveyor actually confirms that local globularity isn't real because the mountain contradicts the globular surveyor measurement. That's
what survey
dude.
measurement?
Dude, what you just referenced, sending people out there.
There hasn't been a surveyor out there.
Didn't you just say that?
There has not been a surveyor out there. I'm saying what he will measure.
Oh, my bad. I misheard you. I thought you said that he did.
Now. Okay.
Oh, so he will measure the globe prediction. Oh, okay. So you have nothing.
So yeah, after corrections, he will quote unquote measure the globe. But as this star intersects, yes,
no corrections. No corrections. He's going to point his theodolite at the mountain and read off the number. That's it. No corrections.
I'm not pointing a theodolite at the mountain. I'm pointing a telescope at it and watching the star disappear.
Did you not measure the angle with that transit?
The timing that the star gets occluded measures the angle.
No.
That's it.
Did you not measure the angle with a transit?
Oh yeah, he did say that he did measure that.
Right.
Yeah, 2
Yeah,
degrees,
that's
31 arc minutes.
Are we
that is
throwing
not
that out?
part of the transit is not part of the celestial theodolite. The celestial theodolite can be done with your eyes, with binoculars, with a telescope. You don't need to use a transit nor a theodolite unless you just want to mess with people who are convinced that the angle matters. Because
You're
the
throwing out
problem
your
with
measurement.
all of those observation methods is that there's refraction present. We've
Right.
eliminated the impact of refraction between the
No, you
observer
haven't.
and the peak by recording the exact moment the star disappears behind the peak. Now that we have the time it disappeared, we know that we saw the actual star occluded by the actual peak, and refraction, no matter what refraction angle that occurred at, we know that the peak actually occluded the star. Now we go to see what was the actual uncorrected elevation of that star at the peak at the time of occlusion. And what do you know? Every single time that agrees with the flat Earth prediction.
How did you stop light bending?
Ruhif,
The,
dude,
the,
that's
the
so
Ruhif!
sad,
mountain peak, the mountain
Looking
peak
at
bro.
stopped
gravity,
it.
Ruby.
The mountain peak stopped it, and we know the mountain peak
Right.
stopped it because the star we watched go down on the peak disappeared.
Right.
Well,
But does that necessarily require a straight line of light? How did you stop it bending?
What are
Look
you
at the
talking
screen.
about? Oh, your little
Can we,
picture?
Gio? Can we stop with the peanut
Dude,
gallery?
it's
No,
not
for
relevant.
real. It's not, dude. What you're doing is taking the point and missing it and going, I want it to be about this other thing. The elevation of the mountain is confirmed by the time in which the star is intersected. The angle matches it. You can calculate it out. It's basic
Yeah.
trigonometry. This is the only
Yeah,
time I've
again,
ever
what
heard
is
you
that angle?
guys 2 degrees, 31 arc minutes.
Yeah.
Stellarium.
Dude,
Hey.
I'm showing you screenshots of Stellarium doing it. Like
Yeah.
we
But
have
not from his house, right? He's looking at it from his house. What is the prediction from his house?
That is irrelevant. What
No,
matters
it's
is
not.
what time did the peak occlude the star?
I understand.
then
Do not
that's it.
understand your
understand.
If you
argument,
understand it, then GG. It's been real.
right?
It's been we had a
GG.
good time.
Yeah.
If you understand
Let's
it,
Let's
if you
put the observer somewhere he's not.
Ruhif, if
hold
you
on.
understand
Then
it,
Stellarium.
then it's over.
I agree it's over because this is rubbish. In what circumstances would you put the observer somewhere he's not?
What?
You're putting the observer on Pike's Peak and getting the angle from there and trusting it. But then when you put the observer where the observer actually is, Stellarium's wrong, isn't it?
It can
If
only
you
be
have
physically
if you have
occulted
refraction,
at that time,
Second.
bro.
if
You're
you have
actually
refraction,
Go
go
ahead,
ahead.
using a
Mike.
Sorry,
straw
Mike.
man argument, Rue.
Speak up, Mike.
You're making a straw man argument, he said, and I agree.
A straw man. So you guys
Yes.
have put the observer somewhere he isn't and accepted Stellarium's prediction as correct. But when you put the observer where he actually is, Stellarium is way off from the measurement. And you call me straw manning.
Hey Mike, where were
That's a
you when you
straw man
observed
argument.
that star getting occulted?
I was at my house.
All right,
Right.
GG.
All right.
So put the
GG.
observer.
GG,
observer's house.
dude.
Oh, you guys are a joke.
No, okay, here, I'll explain
Yeah.
it. I'll explain in layman terms. He took a flat Earth prediction angle, okay? He got 2 degrees, 31 arc minutes, right? Uncorrected, no refraction correction, okay?
Yep.
Then he applied the refraction correction, and he got 2 degrees, 46 arc minutes, all right? That's the globe refraction prediction, correct?
That's after adding it twice. That's after adding it twice. Because the first one there
He's
for
at
the
his
ground. Hold on one second. Let me clarify for Beast real quick. Because
Clarify, yeah.
for the first measurement on the ground to the mountain, they're going to add 15 arc seconds. So they're going to, because of globe slant, they're not going to have a raw calculation. It's going to be off by 27 arc minutes. Now after that though,
the star.
the elevation for the mountain, how you would calculate the elevation of the mountain on a globe. So anyway, you're going to be off by 27 arc minutes from the flat Earth prediction, and then you're going to add 15 arc minutes for refraction. And then when you get to 1 second, and then when you get to the top of the mountain, you're going to add another 15 to that. So you'll have a total, and that'll total 2 minutes and 46 arc minutes, which makes up the difference for the 27 arc minutes that the globe slant removed from the elevation peak. So they're bringing it back to a flat Earth prediction with refraction corrections, and that's basically like we're trying to tell them like that's completely irrelevant to what you're doing because the confirmation of the angle is in the timing of the intersection. So anyway, you can unmute now. Anyway, continue.
Was I muted? Sorry. Are you adding 15 minutes of refraction to the mountain?
When you go to the peak of the mountain, yeah, you add another 15. Yes.
Why?
That's what Stellarium does to get the angle. That's how you get it to match up to 15.
Stellarium's looking at stars, not mountains that are 50 k's away.
Yeah. So look at this. When you do the observation and you turn refraction back on, you get 2 degrees 46 arc minutes. So the only way to do that would be if they were adding like 15 to the original observation. So like on the ground when they get 2 degrees and 4 arc minutes because they had to subtract 27 arc minutes for the globe slant. But then they add 15 back on, so they get 2 degrees 19 arc minutes. And then when you go to the peak, you add another 15, which gives you 246
for the globe prediction.
What?
So you realize
if the mountain is 500 meters away, should you add 15 arc minutes of refraction? What if it's right in front of your face? Should you add 15 arc minutes?
Well, these are the only ways to get what you're saying that the surveyor would go out there and measure. These would be the only way to get these. So like, I don't know, man. I just work here.
No. The globe prediction unrefracted is 2 degrees 17 minutes. With refraction, it lifts it by about 2 arc minutes to 219.
Okay, well, it's still not 2 degrees 31 arc minutes, which is the
Correct.
actual confirmed angle that the star got occluded by.
No, if you are at his house, the predicted angle to the mountain is 219 on a globe, and Stellarium's prediction for the star is 219. So what do you think will happen when a surveyor goes out there and measures the angle properly?
Dr. Mike, go ahead.
I'd like to jump in because what Rue wants to keep doing is moving this to my house.
Where were you again? Sorry.
And you'll see my name written all over this slide from Heffron, from Heffron, from Heffron. Rue, the only way Rue can make the globe Earth prediction work is to move it to my house, despite the fact that it's not my house that's occluding that star. It is Pikes Peak that is occluding that star. So once I see the star disappear at Pikes Peak, I know wherever the star was relative to Pikes Peak was the actual angle I observed it at. When I look at the uncorrected elevation of that star from Pikes Peak, it is 2 degrees 31 arc minutes. That agrees exactly with the flat Earth prediction of 2,226 meters over 50.7 kilometers. Take the arctan of that, and that gives you 2 degrees 31 arc minutes. So the peak occluded that star at the exact elevation angle predicted by flat Earth. And it was the peak that occluded that star, not my house. It's irrelevant where I view it from. If I view it from half the distance at the same predicted angle, it's on the same plane of observation. If I observe it from a valley twice as far away at the same predicted elevation, it's the same angle of observation.
So even if you were twice the distance, even if you were twice the distance away from your house, observing the Pikes Peak, it would still be occluded, or the star would still be occluded by Pikes Peak at that time.
As long as the altitude difference over the physical difference is the same. So basically what we're saying is anything that's along the predicted flat Earth elevation angle of 2 degrees 31 arc minutes, no matter how far away it is from that peak, if the flat Earth prediction is that angle, everybody along that plane of observation will see that a star occluded by the peak at the exact same instant in time. And this is why Rue needs to move this to the location of the observer so he can get all these globe Earth corrections back in play.
All right.
Can I ask a question?
Sorry, Gio. Just to clarify.
Jesse has a question real quick.
All right, go, Jesse. I've monopolized.
It's quick. Dr. Heffron, thank you for coming, by the way. You do realize, of course, that you can get Stellarium to give any angle to a star you want by simply placing the observer wherever it takes to get the angle that you want, right? So you realize that, right?
So I'd have to say the fact that you asked that question means you too missed the point that it's not any observer who's occluding that star. It is Pike's Peak that is occluding that star. Therefore, you need to see where the star was relative to Pike's Peak. If you choose another peak like Ayers Rock, you see where that star was relative to Ayers Rock. The point is you need to set Stellarium whatever it was that occluded the star, not to the location of who observed it.
I disagree because I recently did a test with a real Theodolite that measures to the nearest half an arc second, and I measured the angle to the sun and recorded the exact date and time, and I put Stellarium for my actual observer location, and it matched. But is it also true that your observation of the occlusion of the star also matches what would happen on a globe?
Could you repeat that question?
Yeah, is it true that your observation of the star and the results from Stellarium would also be what we would see if Earth was a globe of the claimed size?
Now, are you talking about the observation from the location of the observer?
Well, you moved
Let me ask you a counter question. Did something occlude your observation of the sun?
Nope.
Then
The
it's not
answer is
relevant.
no.
But I don't see how
It's
that's
very,
relevant.
very
Dude,
relevant.
it's super relevant, dude. Like the entire point of that, it was like your example was, hey, here's a thing that I did that's not the same thing, and that was accurate. Like the whole point of this is the occlusion timing to produce that. So without that, you don't have anything analogous. And so to answer your
You're using
question,
Stellarium.
1 second. And then so to answer the question about it being the same, no, not with refraction. This is the whole point of it, showing that the elevation angle is true to the flat Earth prediction and not the globe Earth prediction.
But
You
on a
just
globe,
share. Oh, sorry, Jerry. Jesse.
going 31.5 miles closer would cause the angle of that star to rise. Is that correct?
There again, you're trying to compare an unobstructed globe Earth prediction with an obstructed flat Earth prediction. Way we've eliminated all those refraction corrections is by having something occlude the star that's being observed. And it seems like you want to keep moving that to the straw man that, oh, I see a star that's not occluded and it's giving me a correct angle of elevation. Therefore, you must be wrong. But that's not the same situation because your observation was not occluded specifically eliminate the problems with the refraction corrections.
So if I'd
Right.
held my hand up to partially occlude the sun, would its apparent position have jumped and changed?
It's totally not analogous.
I asked him.
Oh, come on.
No, dude, not even analogous. That's the answer. We're talking
That's
about a
gotta be
physical
right.
obstruction. Dude, when you say you guys, and we're talking about a dude who just said, if I put my hand in front of my face to occlude it, does that count? As if that's analogous to the situation. And you said, are you guys serious?
Of course it is.
Ruhif, what's your next question, sir?
Next question. Mike, why are you using a globe formula to calculate distances?
Are you for real, bro? The spherical
Yes.
coordinate system that derives distances based off of units of measurement derived from the coordinate system? Bro, you've been down this so far. Stick to the actual point that the star occluded a mountain at a specific elevation angle that's only predicted by a flat Earth. Stick to that actual point. If you want to play fuck around with Haversine formulas, bro, this is you and Shane worked this out months ago. You know the answer to this, but you don't acknowledge it. So you're going to show up. Hold on 1 second, and you're going to show up here and completely non sequitur and go, "How did you get that distance with my Haversine?" As if you don't know that we know how. Not relevant. Not no. It, dude.
Okay.
Nope. You know the answer to what we just said about units of measurement and how you calculate distances on the coordinate system derived from positions of the stars. That's not relevant. What our entire point is that that's a spherical coordinate system and it doesn't represent the shape of the ground. So when we do something like have a star that occludes based on a specific time and elevation angle for a flat Earth, that's the mutually exclusive prediction that shows that the correct interpretation of the coordinate system is with respect to a plane and not a globe.
All right, can you see my screen?
Yeah. Plane trigonometry.
So you guys say the Earth's flat and the globe's like, just a flat map wrapped around a sphere, but somehow we use the Haversine to calculate distances, right? What's the difference between that and the opposite of that? So the Earth is actually a globe and the flat map is a projection, but to work out distances, we use something like the law of cosines on a flat.
This is non sequitur.
It's relevant, dude. It's relevant to the coordinate system. We've already been over this. Go back to the actual point now.
Yeah,
so actual points line. Yeah, dude. We not only have we acknowledged it, we have videos about it explaining it.
All right, next point. Next point.
Well, Ruhif, hold on, dude. Okay, so hold on. If you're trying to actually rebut this, though, Ruhif, like the direct thing of what the presentation was on, then I mean, can anyone say that he has sufficiently done that, or would anyone else like to do so? Because like it really hasn't been rebutted. So it seems like now you're trying to divert into a whole bunch of other things, which depends on whether we want to go down those roads or not. But
if they are using Haversine to work out distances, then they're admitting the Earth's a globe.
No, bro.
What?
That is the most pathetic form of argumentation. Because we've already went over that it's a spherical coordinate system with position. Bro, your concession is noted. Your concession is noted.
I have a question.
To calculate distances.
Are you drawing straight lines on a Gleason going east-west? That's insane.
Liliana?
Well, isn't that the flat Earth map? Or do you not have a map?
Do you not know how to use the tool that you're referencing, or are you just going to say flat Earth map like this is a different map from the one on the left that you're showing? Bro, it's the same coordinate system. You're not going to sit here and trick us and obfuscate. Stick to the actual point. Can you go back to the beginning slide where we were talking about elevation angles instead of obfuscating? Because if you're just going to obfuscating, then we're pretty much done here.
All right. Settle down, princess.
Oh, Alan?
All right. I've got 3 more points and I'll be quick.
we can shit. Hold on, Ruhif. I'm just gonna put you on mute for a sec. Just chill for a sec, dude. Just hold on for a second. We'll bring you back in, or we'll do something. Depends on what you want to do, Alan. Let's let Liliana go.
Q&A. Yeah.
Well, she's been.
Sorry.
Go ahead.
Oh, thank you, Gio. Real quick, Vesicles had started to explain things in total layman's terms, and I was really enjoying it. And then I was wondering if he could kind of just quickly finish that and give us a layman's summary of what was said and all that, like he was doing, just for the audience sake, because I think he did a pretty good job. And just
And
in
correct-
layman's terms, because Alan
Correct
is
me at any
more
point
on
too, by the way.
PhD level.
Well, you can correct me at any point too. So, Dr. Mike took an angle to Pike's Peak, right? Just using plain trig, no refraction correction from his house. Got 2 degrees, 31 arc minutes. Now to confirm that angle, he also took the timing of a star, Stellaris 39, right, to when that peak would actually occlude that star with the celestial theodolite. So what's important about it is that it got occluded when at the same time. Hold on, I'm butchering this. What's important about it is that the refraction correction that is needed to save the globe, if that gets invoked, then the star would not be in the spot to be occluded. It would not be occluded by the Pike's Peak. If you use the same refraction correction, because it's the same optical corridor, right? It's the same.
Yep.
You're looking at the star, right? It gets occluded by the mountain. All right, that's a physical mountain. You can't remove the mountain and put the observer back to the house. That's not the point. The reason why you use Stellarium and put the observer on Pike's Peak and use an uncorrected refraction, right? There's no refraction correction, and it also matches 2 degrees 31 arc minutes. Right? So far, so good.
Yeah, yeah.
The
I
o-
think this is
All right.
important.
very,
enough
very
for you
good.
to
The only
do.
mistake you made was 39 Aquarii.
Oh, Aquarii. Sorry.
All right. Do
I
you
have
want
a
me to go through
question.
3 quick points?
Someone
And then
else said they have a question
yeah,
real quick,
all right.
Yeah.
Ruhiv.
Yeah, I have a question. So when using Stellarium, you key in a location. And when you key in that location and query the angle to a star, it's from that location. And when you calculated the angle to the mountain, you calculated from that location, the house. So how can you compare two different angles from two different locations?
So if I were a lawyer, I'd say this was asked and answered. But the point is, it wasn't my house that occluded the star. It was Pike's Peak that occluded the star. That's why you need to know where was that star relative to Pike's Peak with no corrections for refraction.
So when measuring an angle, you come from a vertex. Comparing the angle to the mountain and the angle to the star has to be from the same vertex.
Now, if you think about what you said, you'll realize that what you want to do is force me onto a globe Earth vertex so that you can argue, oh, I should see it where the globe Earth says it should see.
No, I was
Where
just
it
trying to
says I
reduce
should
the
see it.
number of vertices to one.
So what I did is eliminated the observer as the vertex at all. When I calculate what the flat Earth says the elevation should be for my house, not corrected into globe Earth coordinates, I just measure the elevation of the peak above me divided by the distance away it is, take the arc tangent of that. That tells me I should be seeing it at 2 degrees, 31 arc minutes. Now I watch that star, and at the exact moment that Pike's Peak occludes that star I'm observing, that's when I go see what was that angle on Pike's Peak. And at that moment on Pike's Peak, that angle was 2 degrees, 31 arc minutes. So, and that's the true uncorrected position of the star. That has eliminated all the refraction on both ends. And since the globe Earth is actually built into the refractions, that tells me this is a flat Earth measurement.
Got it. That actually kind of clarified for me a little bit better. So you basically took an angle to the star from your house, or to Pike's Peak from your house. Boom, 2 degrees, 31 arc minutes. Bang. Now using Stellarium, you put the observer on Pike's Peak to see the same time that star would have been occluded, right? And you got the same angle. So it's like taking two straight lines to the star and combining them, essentially. Basically showing that it's a flat Earth prediction that is basically accounting for it, rather than using any correction.
You just said the star would have been occluded when you're standing on the mountain. It would have been occluded by the mountain that you're standing
No.
on.
So you put the observer on Pikes Peak, right? You put the observer on Pikes Peak at the same exact time where Dr. Mike saw the star get occluded from his house, okay? The same exact time. He took another elevation angle with Stellarium, right? Uncorrected, and got the same angle, 2 degrees, 31 arc minutes.
But not from his house.
That was the original angle to Pikes Peak. So using Pikes Peak as a physical indicator that, it's not refracted. It's a
Yes, it
physical
is.
mountain. It's a physical mountain. It's blocking the star.
I just
Okay.
can't wrap my head around having two locations.
It's pretty simple. It's imagine you're making a straight line to the Pikes Peak. Now you extend that straight line to the star, right? It's very simple.
Yeah, if you can tune into my stream real quick, there's a little diagram that kind of shows what Beast is describing here if you want to look at that.
There you go. Right.
Well, he just asked if you were saying that the star was occluded when you were, someone was standing on the peak. So
Well,
he
what?
didn't even understand your point.
Right.
Yeah. Beasticles explained it perfectly. He said, picture a straight line that's cut in two. The guy
Exactly.
on the peak is looking at the star. The star's not occluded for the guy standing on the peak.
And it's the same elevation angle that matches Mike's original flat Earth prediction, right? To Pikes Peak. So using Pikes Peak as like a crosshair to know when that star is basically going to occlude behind the mountain. The first angle is 2 degrees 31 arc minutes. Great, no refraction needed. We're not even talking about refraction. Now you take the observer, you put him on Stellarium, you put him on Pikes Peak with Stellarium, okay? There's nothing occluding the star. It's the same elevation angle, 2 degrees 31 arc minutes. Very simple. You guys, the Globers, you guys need refraction to save the ball. But by doing this, you basically eliminate refraction because you're using a physical object to obstruct the star, which is the mountain. You can't make the mountain disappear. GG.
All right, can I ask a question? A double banger. Number one, Mike, will you allow a professional surveyor to come onto your property? And two, if he measures around 2 degrees 19 minutes, what's your response?
The answer is no. I will not allow a professional surveyor because you are not yet grasping the concept where anything is observed through the refraction of the atmosphere is irrelevant because we have removed all the effects of refraction of the atmosphere by observing the peak occlude a star that is at a elevation on the peak.
So when I send a surveyor to the benchmark, which will change it by about an arc minute, would you like me to message you to say when he'll be there so that you can go and watch?
Answer me a question. Why does the surveyor need a
Doesn't matter.
benchmark to know what elevation he's looking at?
Yeah, Ruhif, if you can take this knowledge and information and you can go replicate this anywhere you want on Earth, you don't have to, try to come onto other people's properties and things. Like this can be replicated. That's the whole point.
He made a measurement of 231, right? I claim it's 219 if measured properly.
Bro,
What do you mean if measured properly?
The mountain measured it, bro. The mountain and timing measured it, Rude. Like what Gio just said, you can go do this yourself. Like you don't have to do it on Mike's property. This is the beauty of this.
Neighbors.
You can use any mountain.
Irrelevant. Like you could do it anywhere. Yeah, that's the point of this.
Okay, so his flat Earth prediction is 231, right? And if it measures 219 done properly, then what?
It's already been measured properly by the occlusion timing of the star, dude.
There's no, you can't get out of it.
Prediction is 219 for both the star and the mountain.
Okay, hold on, wait. I got an idea. Ruhif, do you agree that if you put the observer on Pikes Peak and take off atmospheric correction on Stellarium, that you would get 2 degrees 31 arc minutes for Stellaria 39 at that time?
233, I think, but close enough, sure.
Close enough. That's within the error margin of plus or minus 2, right?
It's
So you would accept that,
233,
correct? All right.
I putting the observer somewhere else is rubbish, and turning off refraction is rubbish.
Ah!
What? It's not rubbish if it gets physically occluded at that angle. You've already said that the mountain would physically have to be at that elevation angle to occlude it. So the fact that it gets occluded at that timing confirms that angle, dude. Yeah, you can't say yes and then no,
Show my
dude.
screen. Show my screen.
It
Bro,
confirms the flat Earth prediction angle. It confirms it. You can't get away from it.
Yeah, what you're
But your
showing
question-
isn't relevant, dude.
Yes,
Question.
This is what's happening. This is
I have
actually
a
what's
question.
happening in reality. Yep.
Oh,
That's what you
let's let him
believe.
ask a question. Go ahead, whoever that is.
Okay, so the 231 from his house is the angle to occlusion. If he were to back away from his house, say 4, 5, 8, 10 miles, would that angle still be 231?
No, it wouldn't.
No,
But the
you would
thing
have a
is-
different baseline.
No,
it
it
Right,
would.
so
If
then
you
if he
have
got-
Logic Peak,
So then if
you
he
have
got
Logic
closer,
Peak show that.
so then if he got closer to the mountain, would it still not be 231?
No.
What?
The angle
So
increases
Alan,
with
Alan,
proximity.
can you show the
Well, then
Logic
if he
Peak
went all the
angle?
way to the mountain, it would still not be 231.
Hang on one
What?
second. Say that again,
What's he
Mike.
talking about?
What I'm
What-
asking is, can you show the Logic Peak angles? Because that answers his question.
Blodgett
Okay.
Peak right here, 35.9 kilometers, elevation angle of 796 meters. Your theta is going to be 1 degree, 16 arc minutes.
And the stars I watched occluded were 1 degree, 17 arc minutes. So plus or minus 1. On all of the stars I actually observed, it's a pointier peak, so there were fewer stars hitting it. But it's a different elevation, it's a different distance, it's a different angle. Exactly as predicted by trigonometry, when you compare it to the Globular's predictions above, radically different.
So you're comparing the angle at the mountain to the angle at the house, and if you went farther away, you'd still be using that same 231.
No.
Oh,
I
no,
know.
no.
That's my point. That's my point. It's 231
What's your point?
it's 231 from the house. It's not 231. It's not 231 at two locations.
All right, Shoe Bill.
At
If
that
you
moment
move,
in time, it's 231 for everyone, everywhere. At that moment in time.
Everyone everywhere. So if I were to
Right?
look out,
No, at his longitude. At his
Yeah, from
longitude, right?
So more
Yeah,
specifically,
from his location,
anywhere-
Shoebill, it's from his
anywhere on the
location, and then also from the top of the mountain, so from 2 different locations.
So what I was going to say is, for anyone anywhere on the Earth who sees that star occluded by Pikes Peak at the exact same instant that I did, their flat Earth calculated angle of elevation will be 2 degrees 31 arc minutes. And for Blodgett Peak example, anyone who sees a star occluded by Blodgett Peak will see it at an angle of 1 degree 16 arc minutes. It doesn't matter where they are on the Earth. If they see that same star occluded at the same point in time, their calculated angle of elevation will be the same 1 degree 16 arc minutes at the elevation of the uncorrected elevation of the star actually is located at relative to that peak that occluded it.
Can I run through my questions? Shall I take a few minutes?
So before we get to your questions, did you understand that, Shoe Bill? Hello? Are you there?
yeah, I have some gross disagreements with it, so I'll just mute.
Okay, no worries, no worries. Okay, Rue.
Well, it
if you-
just sounded like it sounds like he was saying that he thought it was from 2 different locations looking at the mountain, and therefore, yeah, it would be different, of course, if you were in 2 different. But no, it's just that the 2 locations are the point on the ground and then the mountain itself. Because when you then look from the mountain, which is interesting, because then when you have a horizontal, that's like parallel, of course, on a globe, which is why in those drawings there, yeah, it shows how the horizontal from the peak is like at a completely different angle because it has to go around a sphere rather than being parallel to the ground, which is
Well, and at first principles, where he calculated the angle to the mountain with a simple Pythagorean, first
Yeah.
principles would be to measure that angle and see if a measured angle matches what you predicted with the Pythagorean.
Yeah, it does. By using the star and that
No,
time that it got occluded. Right.
And that's why I wanted to back up a step. He calculated the angle to the mountain, and then you want to measure the angle to the mountain to see that the measurement equals calculation.
Right.
It does, otherwise it wouldn't have occluded it at that time, though.
No, and that is the point of contention. So if he
Wait, what?
calculated the angle to the mountain, then
Uh-huh.
confirmed that measurement by measuring it.
What?
He didn't
Forget
actually
the-
measure the vertical angle with
Yeah.
his theodolite. He just did trig.
Measuring it at what, though? Like the specific time, which is
No,
what
I know. Okay,
gives you the
let's go to
confirmation
daylight.
of it, though.
Let's just go to daylight, and he calculated the angle is
Nope.
231.
Why are
Then-
you going to daylight? You can't see
Bro.
stars in the
I'm just-
daylight.
Because he calculated the angle to the mountain by a Pythagorean, and I question that. And will that equal observation of just the angle to the mountain?
Why are you using a different
That-
time of
that-
day?
That's why we're
Because I'm
using.
just
That's why we're
measuring-
using the star to get the physical occlusion, because otherwise
Okay.
the angle would be different. It would do it at a different time. If it worked at a time that corresponded to
I'm
that would
only-
give the globe angle, everybody would be super excited.
But the angle to the mountain is a constant.
The angle to the
So-
mountain is a constant. What do you mean?
Yes, from his house,
What?
from his house, there is one angle, one vertical angle to that mountain, regardless of time of day.
Right, and
So-
then to confirm it, you would use the star's time of
Yeah,
when
this-
it gets occluded
it's-
by the
No,
mountain.
No, you would
confirm-
measure the angle.
I would
So-
confirm it by an instrument measurement.
It's the celestial theodolite is the mountain and the timing that of it being occulted. Confirming it with the instrument on the ground will give variations throughout the day, right? That's why this is so important, because the timing of the intersection in that relevant elevation, like based on the predictions, right, gives two different mutually exclusive outcomes to tell us what time
Are you
it would
Are you
based on
basing the-
elevation. Go ahead.
Are you basing those assertions on your field experience?
Who cares? That's appeal. Who gives a shit?
No, hold on. We're just basing it on plain trigonometry. Like I've had surveyors calculate this out, and it worked. Like the calculations aren't wrong, right? That's not what's in contention, right? Trying to make it about confirming the angle at different times of day is where people have taken the argument, because the timing actually refutes all of that. We've superseded any fluctuations or necessary refraction corrections needed, because the mountain is physically there to occult it at that time. So that part is the celestial theodolite. This is like the most accurate theodolite known to
So
man.
good, dude. It's so great. Dr. Mike, well done, brother. Well done. You took out refraction as their line of argumentation. They can't
So
say
what-
refraction. They
Okay,
can't.
Stellarium uses the J2000 celestial ephemeris, correct?
That's a Dr.
you
Mike
can
question.
Correct it for the date, but yes.
Hold on.
Yeah,
hold
so
on.
so
Let's
it's
let-
using the
let-
celestials. It's using the same celestial that all sextant users and any geodesist would be using, right?
Yep, it's using is it using that GG Bennett coefficient for the cell nav, or like for the celestial refraction or whatever. So it's like using that uniform correction that got kind of standardized, so that everybody could kind of use it without having to know the exact refraction values. It would be like it would average out or whatever. So like that's the one they're using.
It's all right, you guys. It's all right.
All right.
Flat
can I
Earth
finish
is
off the
like-
questions?
Oh yeah,
Just cool.
sorry.
What to do.
Yeah, sorry. Go ahead.
All
Send
right,
them.
very
Hmm?
quick question for Mike. Would you like to be notified when a surveyor actually does get out to the neighbours, so that you can go and watch it and check it?
No, I don't want to know,
No?
because
Okay.
a
Very creepy question.
measurement from my house won't tell you anything except what globe Earth corrections predict it should.
Okay.
And
Second
the
question
whole
on
point
the
of contention
screen.
is everybody who knows anything about theodolites know refraction causes their measurements to vary throughout the day. In fact, if you're really well versed in theodolites, you know the transit level is a form of theodolite.
It's a shit
And
form, but
what
okay.
distinguishes it from other theodolites is the fact that it can be swiveled 360 degrees and maintain its accuracy, whatever that is. And because it can be swiveled 360 degrees and retain its accuracy, it's generally slightly less accurate than a standard theodolite that's not a transit level, that can't swivel and maintain its accuracy. But in any case, what you want to do is you want to keep forcing the measurement back to my house um, so that you can miss the point that the peak occluding the star is what established the exact true location of that star from my house and what effectively moved the measurement of the uh, angle to the position of that star on the peak. So basically, I'm using my house as the eyepiece of a ultra precise theodolite. I'm using the mountain peak as the vertical crosshair, and I'm
Right.
using the stellarium elevation, uncorrected elevation of the actual location of that star as the precision readout of what that elevation was.
All right, wind it up. All right, second question. So you said no
Well, hold
to.
on, but well, the thing is, Ruhif, what you would need is you need actually like if you're gonna actually rebut this, Ruhif, you need actually like competing data, as it were. You need actual measurements or some of your own to go out and to replicate this at different areas, different distances, do all of the math. I'm just saying to even have something, you would need actual data. So at the moment, it's like you don't really have anything to because
hold on.
that's the whole. That's the thing.
Geo.
You would have to actually replicate it and then have actually competing data or something to show something to the contrary.
Can you see my screen?
Mm-hmm.
Right.
Yeah.
I've measured a shitload of things with theodolites. I know that you have to. The prediction for a globe with curvature matches the measurements. So I know what he's going to
Yeah.
measure when the survey goes out. It'll be
You just
219.
conceded our point. Thank you.
Say again.
Rest in pieces, dude.
Dude.
Say that again.
But what I
What was the
said is
point?
you just conceded our point. Thank you.
Which is what?
Yeah.
That you have to take into account curvature?
And refraction in order
Exactly.
to match the
You
globe.
have to take into account curvature. We do not have to do that.
You have to make it bend to fit a
Right.
perceived model, a
Yeah.
presupposed
Okay.
model.
Yeah,
Let's
yeah.
go to this slide then. Hold
If
on.
we wanted to confirm that thing's actual elevation angle, we would need a star to intersect with it.
Yep.
So, next question. You said the uncorrected globe Earth elevation is 2 degrees and 4 minutes. Where does that come from?
That comes
This is from your
from
house. Yeah.
yes.
204. How do you get
That
204
comes-
in the globe?
Piezo.
204 comes out from the the arc sine of the distance over the radius. So that comes out to be 20 arc seconds. Yeah.
27 arc minutes. What?
Oh, sorry. Yeah, sorry. Arc minutes. Yeah.
I think your maths is fucked. I'll have to check that later.
No.
Yeah.
It's not too many straws to grasp, Ruhif.
Well, let's check the math. On
get
my math is on the
Wait,
screen.
wait. When you go to Stellarium at his location,
Not
uncorrected,
Stellarium,
it's
Mountain.
204, and then you do the arc sign correction for curvature. That's 27. 204 plus
No,
27 is 231, right?
The mountain, not the star. The mountain. Right. It drops by
Mountain, yeah.
geometrically drops by 202 meters.
No. He's talking about Stellarium predicts that the position of the star
We're talking
is
about the
actually
peak
at
of the mountain.
204.
Yeah,
What
Rue.
what should the angle be on a globe to the mountain?
Yeah, I got you. So it's the arc sine of the distance over the radius. And that gives you, so if you do 57.7 or 50.7 kilometers over Earth's radius in kilometers, you get 27 arc minutes.
That's not how you do it.
That's not how you get the globe slant?
That's how much it's rotated by, but that's not how much it is dropped by.
Hmm.
So when we're talking about rotating the celestial sphere,
We're
right?
not talking about stars. We're not talking about stars.
Yeah, well, hold on.
This is to the mountain.
Yo, Mike, are you there?
204 is the baseline for the star, not the mountain riff. The
We're
baseline for
not
the mountain is
talking about the
217.
star. We're talking about the mountain. What is the predicted globe angle
But that's
to
not
the
what
mountain?
this slide's talking about. That's what I'm saying. You're talking about something
My
different.
question.
Yo, Rue.
My question is, what is
Rue.
the predicted angle to the mountain on?
Rue. That gives you the missing difference due to Earth curvature. So it takes
doesn't.
off. Yeah, it takes off like 600 meters from the thing.
No, it doesn't.
Okay, this slide, is it about the mountain or the star? Do you know, Ruhiv?
That looks like the mountain, given it's got
No, this is the
50.7
star.
kilometers.
This is.
I don't care about the star. The star's not 50.7 kilometers.
Okay, but
the prediction.
Ruhiv, can you let someone else finish talking before you interrupt them to try to make a point that you don't know
Stop
what they're
straw-manning
saying?
my fucking question.
Well, we got to go one at a time, though, Ruhiv. We don't have to mute people, but I mean, if we have to, come on, dude. I don't want to have to temporarily mute you just so people can speak. But yeah, go ahead, bro.
Could you explain the slide, Piezo?
Yeah, go ahead.
Yes.
But don't interrupt. Just no one interrupt anyone, please. Like, just don't at all, please. Yeah, go ahead.
The 204 is supposed to be the true, quote unquote, before refraction, the true angle of the star from his house, according to Stellarium. It's like 204, 205, right? So then he says, okay, what if I just use the geometric correction by taking the arc sine of the distance over the radius? That gives me 27 arc minutes. So 204 plus 27 is 231. Hey, what do you know? That's what I measured. Now, if you go into Stellarium, it says the correction for refraction is 15 arc minutes, which brings us to 219. And then the mountain is supposed to be 217 raw, and then its correction for refraction is like around 3 arc minutes, so it's about 219, 220. So, or no, I think it's 4, so it's 221. But either way, those are two completely different measurements, 219 and 231. The whole point of the slide, though, is that it just so happens that if you take the raw, which is 204, you add the arc sine correction, which is 27, you get 231, which is what he measured and is what is where the star was occulted, and is also what the raw angle to the star is if you transform your location to the mountaintop in Stellarium. So anywhere that you go, his whole point of his presentation is it's just a giant coincidence, right? That I can look at any mountain in the world, I can take my flat baseline trigonometry predicted elevation angle to the top of that mountain, then I can wait for a star to occult that mountain. I can transform my position to that mountaintop in Stellarium and look at the raw uncorrected angle to that star, and it'll be the same angle that I measured with a flat baseline to the top of the mountain using trig.
That's the cool part. That's what we should replicate. Yeah, dude. That's so like. All right, just to explain it one more time. Flat Earth prediction: 2 degrees, 31 arc minutes from the house to the peak. To confirm that angle, you use a star to basically see when that star gets occluded by said peak you're looking at. Then you take Stellarium, put the observer at the peak, and the exact same elevation angle will be apparent. It'll be the same exact elevation angle as if you took a flat baseline and a straight line all the way to that star. No refraction needed. Did I steelman that correctly?
Yes, super. But yeah, their whole position it would have to be that's just a coincidence at every distance to every mountaintop location everywhere.
I'm a little confused on that.
It's a variable coincidence.
I'm a little confused on that though. So I mean, at Pikes Peak, 231. You know, at the house, 231. Aren't they two different latitudes? And I thought if you get closer to a star, you know, rises and vice versa. You know, it sets. So
That's not what they're claiming, right? So what he's claiming is that his measurement, or sorry, first his flat baseline prediction using trig to the mountain. If he uses trig in a flat baseline, it should be a 231. When he measured it, he claimed he got 231. But also, the other thing is that he measured the time when this particular star was blocked by the mountain.
Okay.
Then he used Stellarium to transform his position to the mountaintop and see what Stellarium said that the unrefracted angle to that star was, and it matched the same angle to the mountain using a flat baseline trig.
yeah, but why though? Aren't you getting closer to the star at the mountain?
Right. So the reason why, right, is if you draw a straight line from the mountaintop to the star to the ground, like is what's on the screen right now, the atmosphere
Okay.
off, right? There's one continuous line from the star to the tip of the mountain to the ground, right?
Okay.
That just so happens to work when we actually check the fact that the mountain blocked the star.
I mean, that makes sense if the star is infinitely far away, but if it has an actual position, right, then it should change angles. I mean, that's what you guys have been saying, that the
No, it
stars
doesn't.
will rise. Hold on.
He's going up along the line, though. He's going up along the same angled line to the mountain peak. So it would be the same angle. It
Yeah,
would be
so
different if he was on the ground of the Earth. If he was on the ground and not the mountain at the same point, then it would be a higher angle. But since he's
yeah,
on the mountain peak, it's the same angle.
Right.
yeah. So the point becomes that the differential between what the globe predicts and what the FE predicts is the correction for refraction and curvature. And actually, when you take away those corrections and you don't use them, you can actually use the physical blocking of a star to match a flat baseline prediction.
It's
You
amazing.
don't need any corrections.
Okay, that's I'll take that, the straight line thing. That's a good point. My only thing would be is like, was the mountain actually measured like 231? You know, at the house, or are we just kind of assuming that it's the case because of the star? Like, I get you guys. You guys are using like the the star or whatever, or maybe it was the other way around them. But I know you guys are like sort of confirming one with the other. But I
Fair
think
question. Yeah, it's a fair question, right? So the angle from the house to the Pikes Peak, 2 degrees 31 arc minutes, right? Let's say plus or minus 2 degrees, okay? Right?
Two
To
arguments.
or arc minutes, sorry. To confirm it, right? What would why? How? I don't see another way, like a better way to actually confirm that angle than actually using a star and a physical mountain peak, right? As like a crosshair. Hey, that star just got occluded by that mountain peak. All right, let's go to Stellarium, put the observer on the mountain peak, and measure that elevation angle to that same star at that time. Holy crap, it
Right.
matches 2 degrees 31 arc minutes. So you could essentially take a straight line from his house to that star, and that's a confirmed angle. No
But
refraction needed.
But hold on, that's the thing. So I'm saying, like, I really do think though in this situation it should be like truly confirmed by like using an actual tool and whatnot. Because if you measure something less than 231 for whatever reason, right, then
Yeah.
now you know for sure something's wrong. And I
That's-
and I would and I get it. You guys are saying, oh, the mountain isn't refracted and whatnot. I would say I don't know that. You know what I'm saying? That's why I would say using a tool for this would be more accurate, because you are
so the
assuming a lot.
mountain, no, the mountain is the tool. The timing that it occludes it is the measurement made by the tool. But real quick before we move on and or come back to that, Ruhif has one or two or whatever final questions he wanted to get off real quick. So let's get Ru going so we can get him out of here.
Yep. Number one, your globe Earth prediction is wrong. The maths is just wrong for that. It's not 204. Without refraction, it's 217. With refraction, it's 219.
That's for the star, not the mountain.
I'm not talking about the star. I'm talking about the mountain.
The slide's
I'm talking
about
the mountain. Okay.
Okay,
When
he
I
didn't say
say the
204 was the
prediction for the
mountain, though.
mountain
Oh,
is
okay, so-
217, that's what I mean. I'm not talking about the star. All right, so stop interrupting and saying it's about the star.
You
The
made a
globe
false
Earth
claim. I just had to
prediction.
correct it.
The globe Earth prediction for the angle to the mountain without refraction is not 204, it's 217. With refraction, it's 219. Changes by 2 arc minutes. All right, so I'm going to send out a surveyor benchmark next door, and I am betting that he will measure 2 degrees in about 20 minutes. Would anyone like to take me up?
You still
Are you-
not get this. It's from a flat Earth with trigonometry. It measures different than what Stellarium says it's going to measure, dude. Stellarium
It's on
thinks
purpose.
it's
That's
way
how.
off.
We've been through Stellarium. You guys are cherry picking some value from a place where the observer was not as correct, but then ignoring that it's way different from where the observer actually. We've been through.
Yes, Ruhif, that's the whole point. Yes.
Right. So
Wait, so
Stellarium's wrong, right? You can't use Stellarium then if it's not accurate.
Oh, okay.
No,
You
no,
guys won't
dude,
use it
dude.
anymore then, right?
Yeah,
No, I think it's
Rue,
accurate. I think
Rue.
it's
So
accurate.
How are you gonna do that after all that, dude? That's crazy.
And
It's
if
accurate
I could jump
from
in
where you
just
put
for
the
a
observer.
moment,
Yeah, go ahead,
I
Dr.
want to
Mike.
point out to everybody that Rue is saying it's not the star, but it is the star.
What?
And that may not make a lot of sense to you, but the 204 is where Stellarium says that star should appear to be from my
Without
house.
refraction. Yeah, without refraction. Yeah.
Without refraction,
USC
allegedly without reflection, but how do you get a theodolite to measure a mountain peak 50.7 kilometers away with no correction for anything and have it come out to 204 every time? And why don't they just set their theodolite up at this in my sunroom, measure the elevation and see what it is? Why do they have to reference my neighbor's property?
Because you said no to coming on your property.
Right, and I said that because you
Why
don't
are you asking for it?
understand what you're proposing. You are proposing to measure from my house and not correct for refraction, which can't give you the accurate measurement you said it will. And then you want to call that an accurate measurement. It can't be done.
There's no
If you understand
corrections. Right?
theodolites, it cannot be done.
There's no corrections. He's just going to point it at the mountain and read off the number. He's not
So,
turning on
tell me,
refraction
how
correction
does
or whatever.
Tell me, how does a surveyor read an uncorrected 2 degrees 4 arc minutes every time without correction?
It's the
Doesn't
instrument's
refraction
output.
vary?
Hang on.
He's talking
Are you
about
saying
the
it's been
instrument.
measured?
He's talking about the
You're-
instrument's output, the simple instrument's output.
That
Right,
has
you're
refraction
missing the
included
point.
already, bro.
Where's this
You're-
measurement of 204?
You're missing the point of why do they need to apply corrections in the first place?
If they want to point a theodolite at some distant object and get the elevation of that object, right, they need to apply curvature and refraction corrections. That's not what we're doing here.
Bingo.
We're just getting a raw angle. Point at the mountain. What is the angle? No corrections.
Without corrections, is that angle correct?
It's the angle. It's the measurement.
It's the
Is it
instrument's
very-
output. It's the
Question
instrument's
is,
output,
does
as
it vary
simple as
from
can
day to
be.
day and throughout the day? Does that uncorrected measurement vary throughout the day and from day to day?
From
I
my
say
experience,
yes.
about 10 or 15 arc seconds.
But you ignore refraction, so you can't appeal to that.
No,
That's
man,
exactly
we're
my
not
point.
ignoring refraction, dude. That's
And-
a
and
straw
I'm
man of
talking
our
from
position.
And I'm
So
talking
what's
from
the-
This is why-
experience. I'm talking from experience. The angle does vary some number of arc seconds, not half degrees, not whole degrees, just some number of arc seconds.
Where is refraction in the prediction for flat Earth?
Arc minutes.
If you
We don't need them.
So hang on, Alan just said that they're
We
not ignoring
bypass
refraction.
reflection.
No, you're
You-
straw manning it.
You said that refraction doesn't exist. We're saying to the magnitude at which it applies for the globe, it isn't manifested. That's why that's why the elevation angle of that's why the mountain intersecting with the star at that specific time shows that the refraction that is applied during the day to explain the difference isn't real. Like the mountain's actually at the flat Earth prediction elevation angle.
Right.
That's-
and when
that's
it
the
measures
important part.
219, what happens?
Yeah,
then?
that is what's
No-
key. You
nothing.
have an actual physical.
Nothing.
you have-
Okay. Nothing. All right.
Nothing. The actual mountain peak is at 230.
All right, that'll do me. Yeah, I'll send a
Wait.
surveyor out. If it's at the benchmark, it'll be
Can I
220.
clarify something real quick after he's done?
Yeah, I'll send a survey out. It'll be 220 from the benchmark, 219 from your house. And then that'll match both the globe prediction for the mountain and the globe prediction or the stellarium prediction for the star occlusion. There you go. At the end, mute.
Oh, you need to go replicate it, Ruhif. That's the thing. You would need to go actually replicate it. Like,
Yeah,
unless
I'm
he's
sending a
unless
surveyor
he's
out.
inviting you onto his private property, then that's really not shouldn't even be discussed. Unless he is, and he's not, that I'm aware
Yeah, he
of.
said
So
no, so I'll send it
that's
to the
not.
neighbors.
Yeah, but it's a presentation of what they're showing. So I mean, that's the thing. Like, that's not really what's relevant. Like, you keep focusing on that, like we were saying earlier. But I mean, you would have to actually, replicate and get. Like
You would have to show that star is being occluded at the time that corresponds to the globe prediction to give you that corresponding angle. That's what you're never going to have. That's why you keep making it about the thing that it's not.
It will all be 219.
He's saying
all
it's
219.
Because this is
Gotta
so
burn his
cool
own
because it's
straw
like
man
it
down.
splits the corridor in half, really, because you have from the mountain as well. Now, it would be great to actually go up there and take the equipment and actually get the angle, even outside of what Stellarium gives. That'd be cool too, to like actually physically go there and get it as well. But that's what's so cool is that it's like you're splitting it in half in a sense, because now you have the observation from the ground to the mountain and then from the mountain to the star. So now you've in a way split that in half, meaning any idea of any dramatic shifting that would be happening, the fact that it's all in a line and you have that halfway point reminds me a little bit even with the oil rigs, some of those where you have multiple at multiple distances, or if you have a peninsula that's coming out and you get there's additional things that happen with the horizon that it allows for. And this is equal to that in a way, but more with angles to the star with the way the mountain is lined up. So yeah, it's really a very fascinating way to apply all of this. And it's something that can be replicated anywhere on Earth, with these same principles, and people can, it's just it's like a gold rush. It's open to for so much more data to be, accrued as well. But yeah, being able to kind of split that in half and have that from the mountain forward, you're getting much more of a physical way, like you guys were saying, crosshairs, and it brings in this whole other aspect to it that's just advances and kind of elevates the entire kind of capacity to be able to discern it through these kinds of applications.
Thing is, it's important too, Geo. If this observation holds true, right? Let's just say you do go to Pikes Peak and you do get 2 degrees 31 arc minutes, right? If you actually send somebody up there, then that would prove that they used flat plane trigonometry to map out the stars.
Yeah, so
Yeah.
to be very clear, right? There's 2 different points of data. One is his optical measurement of the mountain peak, but 2 is the time when the star was blocked. And that's actually the most important data point, because it doesn't really matter what his optical measurement to the mountain peak was. What matters is that if you just accurately take the time that the star was blocked by the mountain, that's the important part. You accurately take the time that it was blocked. Then, at that same time that it was blocked at your location, you go to the mountain peak in Stellarium and check what the unrefracted star angle is. The angle it gives you will match the same angle to the mountain using plane trig and a flat baseline from your location. So what it shows, right, is that when they included elevation measurements into their Stellarium corrections to the stars, or not corrections, but projections, I suppose, to the stars, that it was referencing plane trig as a baseline prior to being corrected.
Exactly.
Well, can I say something real fast? I feel like there's an anomaly in this observation if we're assuming a flat Earth, right? So, real fast, I'm going to post a picture. So because what you said earlier, right? If you're following that straight line, right, then yeah, it's always going to be 2 degrees and what is it, 31 arc minutes, whatever, right? But then you said if you were on the ground where the mountain is, right, the angle would be higher, right? So let's in my little diagram here, let's assume that angle, right, when you're on the ground, let's just say it's 5 degrees, right, for simplicity's sake, right? If it's 5 degrees on the ground and then it's 2 degrees and 31 arc minutes as you go up, right? If we're going to follow that pattern, right, the higher you go, the lower that star is going to be, right? But that goes against all observations, though, right? Because usually when we go up higher, the stars also go up higher as well, right? Like there are parts in like South America, right, where if you you can't see the Polaris, whatever, right? But if you go up high enough, you can kind of have it peaking up again, right? Like that's observation with it. That's what we see in reality, whatever. But this is going against that, though. This is going against all the all the observations that we've seen. So I feel like that's anomalous. It's a little weird, Does anyone want to like touch on that?
I don't think it'd be anywhere close to 5 degrees. I don't know how much the elevation would change it. It might be like an arc minute or two. I don't really know.
It's trig, so we can work that out like real quick.
Yeah, but
what's hold on? So what's the height of the mountain, and then what's the distance to the mountain? I can work it out like right now.
Well, hold on a second. The point is, right, are you able to take any position other than it's just a giant coincidence that the plane trig matches angle from mountain every time?
I mean, I don't think. I mean, coincidences do happen, and like, so I mean, maybe, but
it's not every time.
But like, I do want that to like real fast. Give me the distance to the mountain. Give me the height of the mountain too, because I want to work this trig out real fast. I want to see what that angle difference would be. Because if we're dealing with trig, right, then it should be as simple as that. I could just work trig out, for this other angle.
It's in the presentation. I don't know. It's like 50.7 kilometers. I can't remember the height.
I was gonna say, did you watch the presentation, Arma? Because
I came in late.
2,226 for the altitude of the peak, and the distance is meters, and then 50.7 kilometers for the distance.
Okay.
That's 7,300 feet of elevation rise and 31.5 miles distance.
See, so what's cool is that if anyone goes out and replicates this, what's cool is that they replicate it, and then somebody else can replicate what they did to replicate what they replicated, so it can be double replicated.
Once again, the most important point is not what you actually use a theodolite to measure the mountain peak being; it's the time that the stars occlude. The time is what's important here.
Yeah, that's a physical obstruction of the star, which means you can't say the mountain refracted.
Yeah, it's a given time at a given location. 2 different locations, 2 different times.
That's not.
No,
that's not it either.
not
That's
2
also a
different
straw
times.
man. Yeah, it's literally just the time at your location that you see it blocked, and then at that same time you go to the mountaintop and see what the angle to the star is, and they will match.
And it matches.
And it will match, like the angle that the star is from the mountain will match the angle to the mountain from your location using plane trig. The only thing that you can possibly say in a globular paradigm is that is just a pure coincidence. Well, there can't be a mathematical relationship there, or else you're cooked.
This is a single data point that would work also on a globe.
Doesn't work on a globe, and we have more than one data point for it. That's actually mutually exclusive. So when you add like works on a globe too, you realize the whole thing is about it not working on a globe. Like Ruhif's whole point of contention is that it works on a globe and not on a flat Earth. So like I don't like why do you even say things like that?
Well,
he literally conceded. It's on Alan's YouTube that like if this actually happened, that it would support FE and not the globe. But his whole point was that it didn't actually happen. He was erroneous in his measurements.
The measurement with the transit would support flat Earth.
Yeah, but the time is just as important, Ruhif.
That's
the timing with the celestial theodolite already confirmed it though. So it's been real, lads.
How did you get that angle? You don't seem to get that.
From the elevation of the mountain and the sea level relative to sea level.
But you trust Stellarium when you put the observer on Pikes Peak, but then you throw it out if you put the observer where he actually was. Is Stellarium accurate or is it not?
Well,
no.
No. All right, that's it.
No, that's not what we said at all. There's 2 settings for Stellarium, dog. There's refraction and turning it off. So when you say, is Stellarium wrong or right, and you can't use it, blah, 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 it matches the flat Earth prediction of it. So it's right there. It doesn't match the globe prediction, though, for it. So it's wrong there. So hold on. So the issue is the angle is 231. With refraction, it's 246.
From Pikes Peak. Without refraction from Pikes Peak, what's the prediction from the house without refraction?
230.
204.
No, it's not.
Oh, you're talking about the mountain or the star?
Oh, hang on. No, the star is 206 without refraction.
Okay.
Yeah. So what did you measure to the mountain peak?
231.
Right. Do they match?
Okay, are you just going to go in a circle and actually ask questions?
Yes, he
We're
is.
claiming
He
we're
is,
They're
dude.
all gonna
It's
purposely
When you
do.
decide.
Let me ask you a question that's about something other than what you're claiming and pretend it's
Well,
relevant.
no,
to what you're claiming.
not even that. They're gonna purposely misunderstand it this way so that they can defend it. Otherwise, they got nothing. So I think we're done here.
yeah,
All right.
pretty
When you
much
guys
wrapped
decide
it
whether
up.
Stellarium is correct or not, then let me
Nah,
know.
already decided and walked you through it multiple times. So the fact that you have to keep trying to do that on the back end to end the conversation on that is sad. It makes you look weak.
Can you steelman our position, Ruhuf? Try it. Try it.
Ooh, good idea.
You deny refraction and you move the observer to where he's not to get the angle, and then you ignore that Stellarium has a different angle from where you actually took the.
That
Nope.
doesn't sound like anything we claimed.
Very, very
No.
enlightening.
No,
Very good.
Ruhif, can you steelman our position and articulate it in the way that we're arguing it and not how you are trying to interpret it? Because if
Yeah,
you don't understand what we're
absolutely.
actually saying and you do like a sarcastic rendition, then it doesn't show that you actually understand what we're saying and you're internalizing it how you need the argument to be formed so that you can contend with it. So can you steelman our position without any obfuscation or sarcasm? Because like I already said, we're not saying that refraction doesn't exist. And you started off with, you guys are denying refraction to the magnitude in which you guys apply it for daily observations to confirm the elevation angle of the mountain that comporting with globularity that isn't manifested is what we're saying. That's the whole point of this. So to start off your sentence with that is just just do it right or don't do it at all. Just tell us we're retarded.
All right. First of all, you said you don't deny refraction. Where is refraction in the prediction?
Negligible.
I,
It's
I think
neglected. It's a negligible term.
So
It's
is the
a
flat Earth prediction wrong?
no, man.
No, it's negligible because refracted images don't block physical objects.
Well, again, I'll just show you my slide to show you what's actually happening.
Hey,
Okay, we're asking you to steelman our position. So how
yeah,
about
can
you
you
do that?
can
Okay,
you
yep,
can you
he's put the
steelman our
observer where he's
positions?
not. Is that correct?
No, man.
Well, how about
All right.
how about
you have a
steelman
good you have a good day, Riff. It's been real.
Wait,
man.
hold on. What is this argument about refracted objects don't obstruct, what physical things, whatever? What's that? What's that argument? Because last I checked, all right, if you refract something, right, and that thing goes up, right, there's clearly something like behind it, whether it be sky or a wall or whatever, right? It's going to be obstructing whatever that is right behind it, right? Like I don't get this. This is a weird argument. Like you really mean to tell me you don't think refraction can bring up the mountain? But let's say also like bring up this, the star or vice versa. Like I don't get that argument. Like it's not like it could just do it.
Well, your incredulity doesn't detract from the point. So
Here. Check this out. Let's say it's
Well-
2 degrees, 31 minutes to the peak. Okay, from his house. That's what he measured with the transit. Okay, plus
Yeah,
or
that wasn't
minus.
confirmed though. That was sort of. It's
Well,
sort
let's
of.
just say it's confirmed for the argument. Okay. Now, if you apply refraction, this is an uncorrected angle measurement. If you apply refraction, okay, you would have to raise the peak, and then if you want to use the star, right, to confirm that angle, then if you applied refraction, then you would have to raise that star above the peak, and it wouldn't be occluded. That's the point of using the celestial theodolite, to take away the argument of refraction. That's the whole point.
Okay, but the thing is, okay, so are we saying that? Hold on. Okay, so I guess what I'm trying to say is, okay, so we're assuming that the mountain actually does measure like 2 degrees and 31 arc minutes. Like that's what the mountain actually, without refraction. Are we saying that in this little hypothetical?
We even went on TikTok, right? Remember,
Okay.
Alan, that guy on TikTok, 8 inches from out squared, the Globular? He was like, all right, let me do this math myself. He literally did the flat Earth prediction and got the exact same angle.
Okay, well, okay, so let's just say without refraction, the mountain, it does measure 2 degrees and 31 arc minutes, right? I'm pretty sure the globe math was saying that the star, at the very least, would be like 2 degrees and like I think like 9 or something like that, 9 arc minutes or something like that. What was it? 6?
According to Stellarium.
It was 9 arc minutes.
6.
6 arc minutes. Okay, yeah. So I mean, okay, so obviously in that situation, obviously the star is still blocked by the mountain and whatnot, and now but if we bring up the star though, let's say we bring up the star to like, I don't know, 217, 219, whatever, right? Then it's still blocked, right? So I guess what I'm trying to figure out is like, like what's the issue? Like I don't like if we're assuming.
Okay.
Go ahead.
Can I try to help you? So let's just use some different numbers and use really round, even numbers to make it easy.
Yo, Piezo,
Let's say,
before you do it, can we get an MS Paint diagram specialist? Like, you think it'd be worth it to get the MS Paint engineers in here?
I think this one's too short for that.
Okay,
All right, go ahead.
Fair enough.
All right. Let's say the mountain is physically, not counting refraction, just physically at 5 degrees.
Okay.
Let's say that the star is physically at, I don't know, like 7 degrees.
Okay.
But let's say that the mountain gets refracted up to 7 degrees. Okay. The star is not going to get blocked at 7 degrees.
It would move with
because
it, right?
the physical mountain's not actually there. It's just an illusion, and an illusion's not going to block the star.
Well, I would say the reason why it wouldn't be blocked is probably because the mountain and the star would be refracted, but
right.
In that situation,
that's the point, right? You got it.
Okay, so what is the star? What's the stars? What does the globe predict for the star again? At the guy's house, it was 2 degrees.
The raw angle to the star is like 204 to 206. There's Ruh's saying 206, Mike's saying 204. We'll say 205.
And what is for the mountain? For the globe?
The mountain raw is 217.
Okay, so then,
right?
So what is the issue then? I mean, it would always block on the globe. Like you gave me like a non-analogous like example, like like a hypothetical, whatever. Because like you just said that in your example, the star was higher by default, but in the actual,
the star is lower, whatever.
Yeah, well, in this one it's lower now. Yeah, with the actual real life measurement, it was lower. So how was that? Why did you give me the one where it was higher?
Well, it wasn't a real life measurement, bro. That's what Stellarium. Okay. This is hard, bro. I don't know why this is so hard.
No, I mean it's hard because you gave me a non-analogous example. Why did you do that? I don't get that. Like, what was the point of that?
Let him walk you through here. Hold on. Go ahead, Piezo.
Okay, bro.
You don't need to dumb that down.
Physical angles. 2 different physical angles.
Okay. One was 206.
The star is like already underneath. Yeah, the star is already underneath the mountain. Like it's physically not. It's below the mountain already. Okay. They are both said to be refracted, right?
Okay.
You use a different refraction number for the mountain at the same point as you use for the star at the same point, so that you can get 2 different amounts of refraction so that they can both bring up to the same point to make them visible on a globe. That's the only way you can make it work on a globe. That's what they have to do in order to say it's visible at this point. Okay. So they're already doing that, but we're saying, guess what? You don't have to do that. There's a better way. All you have to do is use trig. Okay. Take the trig angle with a flat baseline to the mountain peak. Okay. Then use your stopwatch, use the timer, and time what time that mountain peak blocks the star, and then use Stellarium to teleport yourself to the mountain peak and take the unrefracted angle to the star from the mountain peak, and it will match the trig angle.
Okay, I get that, but so basically though, so then it's reverse. Hold on, wait a minute.
It matches the angle in Stellarium from the mountain peak, which is the important point.
Hold on. So let's just. Yeah. By the way,
shouldn't.
Well, hold on. So why don't you count Stellarium's other angle from where that the house is, right? Like, I mean, if you're gonna use Stellarium as a source, right? Shouldn't all of the numbers be relevant? Or like, how can you...
because you're applying corrections over distance for curvature.
Right. That's the point. It doesn't match because if it's not on a ball, then it wouldn't be there. It wouldn't be at that 2 degrees 6 arc minutes. It wouldn't be there.
Okay. Well,
because the fact that you can use plain trig and time in order to correctly predict an occlusion and have it match a flat baseline, at best in your paradigm is just a coincidence, and it just happens everywhere.
Okay, but I mean, I could sort of like almost make the same.
I got you, bro. So check it out, right?
Oh my gosh, I get it already, dude.
Okay, you get it already. All right.
basically, okay, so the hypothetical heat before, where the star was above, right? It's basically the reverse of that, where the star is below, but somehow, the observation shows where they're pretty much lined up, basically, if I'm getting that
Do
correctly.
you know why it's below though? In
I mean,
Stellarium.
why it's below in Stellarium? I mean, that's just
Because it's taking in the distance between you and the star, right? And it's basically saying, oh, this is the globe prediction. Because you're taking the distance, right? And over that distance, you should be curving downward.
okay.
Do you see what I'm
Yeah,
so like
they applied the curvature in the sky to the ground.
right. So to remove all of those corrections, you take a real theodolite measurement of the peak. You got 2 degrees 31 arc minutes.
Wait,
Go to
did he?
page.
I don't
Just use the
think he
time,
said he
bro.
did.
Just use the time.
But this is
No, he
strange.
based that 2 degrees and 30 minutes was based on trig. It wasn't based on a measurement. Show me the measurement.
That is the measurement.
Did he use his celestial theodolite to measure 2 degrees and 30 minutes for Pikes Peak vertical angle?
You measured a camera taking time lapse footage and the time that it was intersected to confirm the angle.
Right. Here, do you
Well,
actually
why
have
doesn't it
that?
match
Do you have that
Stellarium?
GIF? Hey, Dr. Mike, are you still here?
It doesn't match Stellarium because it's not a glob.
But hold on, you guys don't see the double standard here. You guys are saying, oh, how convenient is that? Like, what is it? Refraction does all that, right? But I could say the same thing. How convenient that you guys have the sky curved this, really, really weird way where, it should only work on a ball, whatever. I mean, I think there's a double standard here. I really do think
It
these,
does. That's not our position. We say it curves in the exact same way that you claim the ground curves.
yeah, and I would say that's like that's just really convenient. You know what I'm saying? I could say the exact same thing.
It is convenient because that's how
That's the
you guys
point.
made your map.
Right.
All,
Like
all I'm
literally, let me give you a quick. It's just like a 30-second. Just here's how your map was made. Pretend you don't know the map. Pretend you have no idea at all what the ground map of the world is. All you know is you can look at the sky. So what you do is you say, okay, what I'm gonna do is I'm just gonna take an orb, okay, and I'm going to go to all these different locations in the world, and I'm going to everywhere I go, wherever I see a star 90 degrees above me, I'm going to paint that star on this orb. And I'm going to do that all over the earth, excuse me. And at some point, I'll have every star mapped to this orb.
Right.
And what do you know? You now have a celestial sphere.
I get that.
And
Right.
now you transpose that to the ground, and you have what's called a graticule.
Okay, I get that. I'm just saying, I think it's pretty fantastical, right? That the sky on the flat Earth just is able to, break trigonometry. Trigonometry seems to work, in this mountain example, but then in any other situation where you're actually moving across the surface, suddenly trigonometry breaks. It's no longer actually where it's supposed to be. The sides of the triangle are, just don't work for the angles that you get.
Celestial
I'm just saying.
navigation uses trig, bro. What do you mean?
Look, all I'm saying, all right, is that the trigonometry works sometimes, and sometimes the sky is just very fantastical, and that's why I think it's just double standard. Where, yeah, come on, you really.
Can you give me an example of celestial navigation where you don't use trig?
I'm not dealing with the celestial navigation right now. I'm talking about just in terms of basically the sky, just being, outside of like trigonometry. Like it's not like you're using it in some cases, right, with the mountain, right, and then but if you actually if you try to actually like locate the star, like the height and whatnot, trig breaks there. I'm just saying, I think it's fantastical. I just think it's a double standard that when we say refraction, that it's so what a coincidence, like I'm just saying. But I digress though, because that's irrelevant. I do think though, all right, that we should get back to the actual topic though. So
yeah, angles to the stars. Angles to the stars.
Yeah, so your position, just to be clear, is that it's a coincidence that the plane trig measurement to the mountain peak also matches the mountain peak measurement to the star?
No, because you haven't actually confirmed that you've used the star, but you haven't actually measured it with the tool, whatever. I would say once you measure it with the tool, we can say for certain.
We
all right?
measured the time with the tool.
Yeah,
What do you mean?
the time is fine, but let's actually measure it with something that actually measures angles, right? You're at the house, whatever, and you measure the angle because
You're missing the point. It doesn't matter. That
I
point
get
doesn't matter.
no, because
we can measure 69.9 degrees with a tool. It doesn't matter.
All I'm saying is that there's a lot of assumptions being made, right? And that's not good. You're confirming you're confirming your numbers, whatever, based off of like a theory that you have. You need to actually confirm it with an actual tool. Like otherwise,
Dude,
you're just making assumptions,
I
and
don't.
that's not.
You saying that shows me you don't understand what our position is. The optical measurement of what angle you see it at does not matter. That is our position. It doesn't matter. So
Okay.
you saying you need to get a tool and measure what angle you see it at is irrelevant. What matters is what time it blocks the star.
Okay.
Because I can use the time it blocks the star, teleport myself to the mountaintop that's blocking the star, and see what your model predicts the angle to the star from that mountaintop is, and it'll match my plane prediction to the mountaintop every
Okay,
time.
but I'm just saying that I'm calling like BS on this. Like I said, because like I pointed out earlier, whatever. Like if you're at the
So you would
base of the
have to
mountain.
contend that the time is wrong. The only way you could call BS on this is you would have to say when he did this measurement and he took this time lapse footage that his time was wrong.
Well, no, I'm
And it
just
just
calling.
coincidentally was wrong in such a way that it aligned with an FE baseline measurement that also matched the angle to the star from the mountain. It's just a giant coincidence. Or
No,
he's lying and it's a conspiracy.
no,
That's
I'm
your
just
only
saying.
logical, consistent position.
No, listen, all right. Like all I'm saying, right, is that I don't think you should be able to use like trig on this. That's what I'm saying. Like I don't think trig should be even an option, right, for the flat Earth because once again the sky doesn't really behave trigonometrically on a flat Earth. So I think it's just really weird that you're using trig in this scenario. I don't think it should be possible. Is what I'm trying to get at.
What the fuck kind of argument is that, dude? All right, with that said, your concession is noted. And if there's any further questions or comments, if anyone wants to take a crack at it, we're probably going to wrap up here.
I do.
Yeah, I have a quick comment. Alan, I enjoyed you and Dr. Mike's presentation. It was excellent. But I have to say that I also very much enjoyed listening to Piezo and Beasticles because they're also able to present things like in layman's terms, and I enjoy both methods. Yours is more sophisticated, of course, Dr. Heffron and Alan, and I love that. And I think the audience also probably feels the way that I do because we get to see both versions of the presentation, which is great. So thank you so much.
I had a question, if I may. Are we in general agreement, Dr. Heffron, that had the incident angle of the image of the mountain as it arrived at your house been measured, that it would have been about 2 minutes 19 or 2 degrees 19 minutes?
So
I don't.
I think the best estimates I've seen are probably 2 degrees 17 minutes uncorrected, and it's the corrections for refraction that are the major point of contention here. Um, uh, and the 2 degrees 17 minutes is a globe Earth prediction. So it's slanted to account for, well, slanted in a funny way. Because I don't even want to go and rocket as 217 because what I've noticed, the reason I developed the celestial theodolite is every time somebody talks about refraction, they're pumping out different numbers: 202, 204, 206, 217, 219, 246. They're just all over the place, and that's why I decided I figured out a two-step process to eliminate for refraction from even being needed to be considered. So step one is let a peak that's at a known location occlude a star. Now you've eliminated any impact of refraction between the peak and the observer because the observer saw that star be occluded, saw the star disappear regardless of what refraction was doing to the angle. And step two of the process is go see where, not an observer, but where the star map says that star actually was relative to the mountain, And that's the 2 degrees 31 arc minutes that agrees with the 2 degrees 31 arc minute at Earth prediction for Pikes Peak. And for Blodgett Peak, I believe it said 1 degree 17 arc minutes versus a 1 degree 16 arc minute prediction. And that's within the range of accuracy I was shooting for. So for all practical purposes, a valid and it's significantly different from the globe Earth prediction. So it's obvious it's matching the flat Earth prediction, but very deviant from the globe Earth predictions, which seem to be all over the place, depending on what they use for refraction.
Can I ask Jesse a question?
Certainly.
Great summary,
Jesse.
Dr. Mike.
Jesse, can you pull out a laser with some maybe sugar water or whatever, get the light bending, and then put an obstruction there and see when it gets occluded?
You mean?
That's a good idea, isn't it?
Yeah, I could do that.
Yeah, that'd be fantastic.
I know.
Because apparently, if the light bends, like it can't occlude things.
Yeah, I'm not sure I understood that, Dr. Heffron. Is it your claim that the lights from the visitor center, as seen through your telescope, were not affected at all by refraction?
So my actual position is that corrections for refractions are all over the place and appear to be bogus because no two people agree on what that correction is. So therefore, what needs to happen is refraction needs to be eliminated. You can't trust theodolite measurements because it's affected by refraction. Laser light is refracted. So what I'm saying is you want to watch the true location of the laser light. But what is the true location of the laser light? Well, if you're beaming it through sugar water, you can see what it is. There's a little bit of uncertainty. But there's not a correction that varies from day to day, from hour to hour, and that always magically agrees with the prediction for a globe Earth, even though the predictions are all different. What this method does is it just completely eliminates refraction by saying we know that if the starlight was occluded by the peak, that was at the true angle of the starlight, whatever it may have been. So now we see we go to where does your favorite astronomy tool say the actual location of that star was on the peak that did the occluding, and that actual location eliminates the need for any refraction corrections because it's telling you where astronomers all over the world say that star actually was. And then what we have observed in the very few experiments performed so far, and like many people have said, this is an experiment that can be performed by anybody, anywhere, on any peak. You don't need to send surveyors to my house. You can do this from your house. You can go out in a parking lot. Just find your favorite peak, find your favorite position to observe that peak from, watch that peak occlude a star, calculate the elevation of that peak above you divided by the distance that peak is away from you, find out what angle that corresponds to, and go into your favorite astronomy tool, find out what the uncorrected elevation of that star was from the peak you saw occluded, and now you have the true angle of that star. And the question is, does it match the flat Earth prediction for that angle, or does it match the globe Earth prediction for that angle?
So,
Well said.
if by experiment we find that Stellarium only gives accurate angles with the atmosphere turned on, then shouldn't we use it with the atmosphere turned on if we want accurate angles?
So in response to that, I have to ask a question. Does everybody agree with your assertion? And I know for a fact astronomers all over the world are turning off refraction correction on Stellarium and other astronomy tools because it misaims their telescopes.
I
that's interesting.
highly doubt that because
Yeah,
when
that's bullshit, by the way.
yeah, because I went out and I've by the way, Doctor, just so you know, Shoebill here is a licensed professional surveyor with more years experience than I've been alive. And I'm a hobbyist, but I own a dozen working theodolites or total stations, and I've been practicing using them for about 5 years now. So we're not new to this topic of measuring angles. So is it your claim then that the mountain did appear, if you were to actually measure the angle with a high quality theodolite, it would be around 2 minutes 17 or 2:19, and that missing height is due to the light taking a non-straight path between the mountain peak and the observer?
So I've stated my position several times, and it's not what you're claiming. And my position is that what you measure with a theodolite or a level transit or any other measuring device varies from day to day, from hour to hour, meaning that you have to correct it to even be able to approach anything resembling accuracy. And so the entire reason I came up with the celestial theodolite concept is to completely eliminate all refraction from the equation. So by observing a peak occlude a star, you know the exact time that star was occluded by the peak. Now the only question is, on that relative to that peak, what was the uncorrected elevation of that star, um, which is based on observations from all over the world. And you can do some research to discover how they get those locations so accurately. But the point is, um, that elevation is the predicted elevation for flat Earth every time, and is very, very different from the globe Earth prediction that varies hour by hour, day by day.
So, for the record, I did a study where took 36 vertical angle measurements of a mountain 75 miles away and 10,600 feet higher than me, at different times of day, at different times of year, across multiple years, using 11 different theodolites, and my average missing feet was 3,200, and all of my measurements fell within a plus or minus 100 foot deviation from that. So it's not true that it's so random that you can't tell. But the more important thing here is, you're using Stellarium in a mode that is not accurate. I have tested Stellarium with and without refraction, and it is not accurate if you turn off atmosphere. If you actually measure the angle that you see a star at, Stellarium will not match that unless you turn on the atmosphere.
And
All right. So
what are
your
you
position is
measuring it
that
with?
it's a coincidence, right?
Yeah,
Well,
so
I think
this is getting
Oh,
hella circular and repetitive now. Like we've just reached the exact same thing. So if there's no further
oh no.
questions,
Oh no, you
Alan,
brought it.
I don't. Hey, for the record, I don't think anyone really gives a shit. Sorry, Jesse. If I may, I just want to give a quick summary because I'm retarded and I just
oh, you're
listened to
good, bro.
this
What's
whole
up?
thing. And I listened to this whole thing, and what I've heard is that over years and years and years, people have argued about no scientist agrees with flat earthers. Here we have a PhD physicist who has come up with an
He's not a
observation.
PhD physicist.
Okay, a PhD. Sorry. Uh, thanks for the correction there, Roof.
So,
You've
so
done
I'll
great.
actually I'll give you a truer correction than Ruhif.
Okay,
I'm a doctor of computer science.
perfect. So we have a
It's
doctor.
Dr. Bennett, who's a PhD physicist.
Okay,
So
that's right. So I don't mean to cut you off, but I just wanted to get this out because what I've heard is that you've come up with this doctor here has come up with an observation, and the only thing in response was, "Nope, nuh-uh, he's wrong. That's bullshit." Straw man arguments and everything, misrepresentation of the argument. And so I just want to say thank you for putting in your time. Dr. Mike. That's really awesome. And man, it's almost brutal listening to you guys try to cope with what he's presented here. He's given you multiple options to go out and look. I didn't. I asked Alan if I could speak, but that's okay. Um, he's given you the opportunity to go do this experiment on your own, and he's explained why theodolites and that. But the nuh-uh kind of thing doesn't work anymore, you guys. Like it's really, it's brutal to listen to when you just say nuh-uh, bullshit. That's bullshit.
Yeah,
So
but
good luck
people
with
have
the
been
army.
testing Stellarium around the world for a long time, and it works everywhere. So
Yeah, we just used it to verify flat Earth elevation angles to physical objects. So that's pretty cool.
Isn't
He
that
doesn't
cherry picking
understand
though? I don't get that.
any of
Isn't that
that.
not?
Is it cherry
It's a
picking if you do it
coincidence.
from different locations, dude? So your
you didn't
position
include
now
refraction.
is that it's a
But you,
coincidence.
Your
no, but
prediction
you
didn't
only took.
include refraction.
It,
Hold on, but
yeah,
you only took.
It's a negligible term. That's why it's not included.
yeah.
Oh,
Officially, the only logically consistent position they're even allowed to take at this point is that it's a coincidence. Like that's it. You don't have another logically consistent position as a globularist that you can take.
Unlucky.
hold on, I'm just. You guys need to really clear this up with me, all right? Because I mean, I'm pretty sure it's like like confirmation bias, right? When you choose, right, or whatever cherry picking, right? When you choose, right, the one thing, right, that works out for you guys, but not choose the other thing, right? The location, of the house, measuring the angle, whatnot. If you measure angle from the house and whatnot, it's a different angle, whatever.
Yeah.
Like I just don't get like.
Yes. So you've been
So
explicitly walked through this multiple times now, and it's not cherry picking. And we have two different points for it. So like the fact that you keep reiterating the same thing and then saying cherry picking shows that you're like either not listening, you don't want to listen, maybe you need some time to think about it and go over it again or something. But the issue here seems to be between the keyboard and the chair. So I think maybe, you should deal with that on your own time. It's already been explicitly shown.
here,
So we're
here, I'll take a shot real quick because
go
Dr.
ahead.
Mike laid it out beautifully, right? He took an angle from his house to the peak, right? And in hearing all of the refraction arguments from everybody, like, oh, 204, 206, 219, 246, he wanted to eliminate the refraction between him at his house and the peak. By doing so, he used a star that was occluded by the mountain peak, right? Boom. There's no refraction. That star was occluded by the mountain peak. That's a physical mountain. Now, to confirm that angle, he went to the top of the peak using Stellarium. You teleported yourself to that mountain peak from Stellarium. Use an uncorrected, no atmospheric refraction elevation angle to the star from the peak. Guess what? It matches the same flat Earth prediction. Now, to confirm it, he used a different peak as well, Blodgett's peak. It works in any peak, and that's why he's saying go to any peak, go to any parking lot, time when a star is being occluded by your favorite peak of your choice, and you can do the exact same thing and confirm the exact same thing. I challenge
Yeah,
everyone to go out and do that.
and the measuring device, because he did use a level transit, but the official position is that that part doesn't matter as much. The most important part is your GPS synchronized timing device that gives you the accurate time down to the minutes and seconds
Look at
of
me.
when the occlusion happened. You check. I mean, he has the time down to the second mark of when it was occluded from his time lapse footage. He said, "Oh, it was occluded at 6 hours and 20 something minutes and so many, whatever the time was. At this second, it was occluded. Let me go at this second in Stellarium to the mountaintop to see what the angle to the star is. Oh, look, that angle matches the flat baseline trig angle to the mountaintop that occluded it. That's it. It's super easy. It's a two-step process. Step one, watch the time of the moment that a star is blocked by the mountain. Step two, teleport to the mountain in Stellarium and see what the true position to the star is, unrefracted.
Or any other astronomy tool. Doesn't
Yeah.
matter unless you want to
And that
actually climb to the top of the mountain that you're looking at. Whatever. But if you want to do that
and
too and use a sextant, sure, but it's not the point.
right, that angle you get in step two is going to match the angle that you get from plane trig. And no, you wouldn't even want to use a sextant, right? Because anything you get with a sextant is going to be affected by optical conditions. The unrefracted angle is said to be the quote unquote true position of the star as given by the nautical almanac. So that's why it's relevant. If you just base it on nautical almanac comporting measurements, the angle to the star atop the mountain is this angle. It matches the angle to the mountain from a flat baseline with trig. There's no answer to that other than it is a coincidence or you timed it wrong. Any other answer is not logically consistent in your paradigm.
Okay, so okay, so what was the angle for the second peak? Because I don't think I got that. The second, because you guys said you confirmed with the second peak, right?
1
What was the
degree,
angle?
1 degree, 16 or 17 or 18 arc minutes, I believe.
1 degree. Okay, and how does that like? What was the other location
And the
to?
star to the peak, Blodgett's peak, was also 1 degree, 16, 17, or 18 arc minutes. I can't remember off the top of my head. It's one of
I mean,
those.
so was there
Point
also
is,
was there a real life observation for that? Because I mean, remember for the one peak, it was at the person's house, right? They saw the star being blocked by the mountain, and then you guys went to Stellarium to kind of like confirm that, right? So was there like the equivalent of that, like where someone was at a physical location, the star was occluded at 1 degree, whatever arc minutes, and then you guys went to Stellarium.
The star was occluded at a time, bro. Listen, it's a time. The star is occluded at a certain time. Let's pretend I don't have a theodolite. All I have is a telescope, and it doesn't
Okay,
have
yeah.
a crosshair, and it doesn't have a leveling mechanism. All I can do is point it at the mountain and follow the star and wait for it to disappear. And I have a very, very accurate stopwatch, okay, or a watch. And I time the exact moment that the star disappears. I use that same moment to go to Stellarium, put that time into Stellarium, and look at that time from the mountain peak at the star and see what its true position is. And the
I
true
get that.
position angle, that true position angle from the mountain is going to match the angle to the mountain from my location using plane trigonometry.
Okay, I get that. I was just trying to. I
That's
was
a
just trying.
spooky coincidence, right?
Okay, I was just trying to clarify because I was trying to get some clarification
I got, but
on the
can I
second
get your
peak, whatever.
point? Like your opinion on like that's a spooky coincidence, right? Like, how do you
Maybe.
account for that? How can that line up for multiple locations? How does that match?
I mean, I didn't
It's
know there
just a
was.
spooky coincidence.
Well, when I
Coincidence?
went into this, hold on. When I went into,
we should
can
have
I just
everyone
talk
do
first?
this.
Come on, let me. I was.
Go
All right,
ahead.
bro. All right,
We're
go
talking
ahead.
at the same
All
time.
right.
There's a delay.
Okay.
Go ahead.
Yeah. So I mean, yeah. When I was like as much as I could of the live stream, I saw a little bit of it, whatever, and I was hearing you guys talk about it, whatnot afterwards, right? I didn't care about the second peak, so that's my apologies, whatever. I didn't, it was never really brought up. It was just mainly the one, Pikes Peak or whatever. Yeah. I mean, I don't know. I guess if you have like the data or something, like send it my way, whatever. I would like to see that, like the other peaks and whatnot, because like I said, I only heard of the one peak, so. Yeah, it would be nice if I could see the other peaks.
So
All
you
right.
could do this yourself
Yeah.
if you just have a telescope, basically. Or I mean, technically, you could probably use a camera if you got like a Samsung that's got a good enough zoom and you got a tripod. You could probably just do it with a camera with a tripod because you don't need an accurate enough angle. You just need an accurate enough time. So, and since the timing on your phone is already GPS synchronized, then as long as you have a timestamp on your video and you go and see what time in the video the occlusion happens, you could use that as your time reference marker to go to the mountain peak and Stellarium.
The thing is, Dr. Mike predicted the flat Earth angle before he even got the Theodolite to confirm it. Just using plain trig, right? You got the elevation of the mountain, you got the distance between you and the mountain, and then you can get your angle, right? The predicted flat Earth angle was 2 degrees 31 arc minutes.
Okay,
So he got a Theodolite to confirm it from his house to the mountain. And he was like, "Huh, this is crazy. How can I confirm it even more? How do I get rid of refraction? Let's use a star and the time when it gets occluded by a mountain, a physical object, to remove the refraction argument between him and between the house and the peak of the mountain. Then you use Stellarium or any other astronomy tool, put yourself on top of that mountain, and see if it matches that angle. And guess what? It does.
I'm not really fighting that right now. I literally just asked for the
I just
data
want
on
you
the
to
other.
hear the logical steps he made. Like, first he made a flat Earth prediction, okay? And then confirmed it with a Theodolite. Then confirmed it with a celestial Theodolite observation. And this is, am I right, Dr. Mike? That's what happened. Just want to make sure I don't want to straw man you.
You stated it very well, and I concur wholeheartedly with your advice. This is so simple. Everybody can try it for themselves. Don't take anybody's word for it. Do it yourself.
Yeah, I'm gonna do it. You know what? I'm gonna go Saber. My buddy Saber's in here. He's been listening. We're gonna go do that, bro. We're gonna come up with our own observations. I'm down.
Make
got
sure you
Lone
get
Mountain
Yeah,
out.
actually, I was just thinking traveling to Missouri in a couple of months, and they have a nice area where all the stars are visible, and I would love to do this. So yeah,
Nice.
I'm
Go ahead,
excited to
brother.
do that. Yeah,
Anyone
yeah.
can do this, and I think that's where we
Also,
should leave it.
thank you. Excellent presentation. Really cool stuff. Fascinating stuff. Thank you.
Can I ask Dr. Mike what his error bars are on his time? Is it down to 1 second? What is it?
On my timing, it was probably plus or minus 1 second.
What does that equate to in terms of error and angle?
On air, that's approximately 15 arc seconds.
Per second?
Right, 15 arc seconds per second off, approximately, because it depends on your viewing angle a little bit. But you get Stellarium will actually tell you that. You can step through it and see how much error is introduced for every second you step. And then, as I noted in my original presentation, there's several other uncertainties. Like I did this with a time lapse camera with a 1 second exposure, 1 second time lapse. So that could introduce another second of error. So now we're talking about 30 arc seconds or half an arc a minute of error. And then in the case of Pikes Peak, there was an additional potential error because the height of the building was, I believe, I put this in the presentation, but I believe that was another 15 arc seconds. So there's a 15 arc second error here and there, which could add up to 3 seconds, 6 seconds. I'm not exactly sure, but even if it was not that accurate, so that you were off by, and I estimated overall for Pikes Peak, my overall accuracy was plus or minus 2 arc minutes. My Blodgett Peak accuracy was plus or minus 1 arc minute. Even if that's off by a factor of 2 or more, there's a clear differentiation between that angle and the angle predicted by the globe Earth model. So it's a no contest. You can clearly see that, yes, it matches one or the other.
So what's the difference in measurement, or what's the difference in prediction from flat versus globe versus the error measurement?
For Pikes Peak, it was 27 arc minutes.
Oh, damn. 27 arc minutes. Okay.
It's a huge difference. And I don't have Blodgett readily available, but I think that if my memory is any good, which it may not be at my age, I think that was 18 or 19 arc minutes difference. So it was way, way beyond the margin of error, the difference in what the two measurements should have been.
Okay, cool.
Interesting that you can get the same results for both models in the real world. I thought that they were different.
Happens to be right for both to work. Not all distances would be, but that one was.
So a cosmic coincidence, right?
No.
So you're saying both Blodgett Peak at 36 kilometers away and Pikes Peak at 51 kilometers away are both coincidentally in the right place to make globe Earth and flat Earth be identical?
Well, you didn't measure a star clipping behind Burgett Peak. You only did it on one place. You only got 1 point using your celestial theodolite.
That's an incorrect comment. I measured many stars on Blodgett Peak and on Pikes Peak. I only took one ever theodolite measurement, and that's the one that made me realize you can't use this theodolite measurement because they require too many corrections, and the corrections are all over the place. That's why I devised this much more precise method of figuring out what is the true angle.
Have you released?
You said before, sorry, Jesse, just 1 sec. You said before that you've stated your position many times. We've stated also many times making corrections to any measured angle. Okay?
Right, and
I'm not
and my
correcting any
contention
angles.
is the fact that you have to make so many corrections to come up with the right number for your model, and I don't need to make any corrections at all for mine. That's a glaring discrepancy in our procedures.
Okay, so I incorporate refraction into mine. Do you accept that refraction alters the position of things?
Yeah, he literally
No,
just said.
no, not at all.
Dude, oh my
What I
gosh.
Yes, no. Yes,
No.
no.
refraction alters the apparent position of things.
Right. So where is that in your prediction for a flat Earth?
So even
If you weren't
during this
listening at
little
all, were you, bro?
discussion, yeah, you're not, and that's my whole point with Rue is
Yeah.
intentionally misunderstanding.
Oh,
I
don't
think.
start that shit. You already went through the
Right.
entire PDF calling me Satan.
No, an
have a
Australian
conversation like an
reptile.
adult.
Get it correct, Ruhi.
Yeah, but it's meant to be Satan, right? Just have a conversation like an adult. Can we do that?
Well, you're the one who can actually steelman our position.
Yeah, you
Dude,
can't steelman
exactly.
it.
Explain the
Do you
concept of
put-
a celestial theodolite, please.
Yeah, you put the observer somewhere where he wasn't. Is that correct or not correct?
Arguing against your misinterpretation straw man, or are you trying to argue what we're arguing?
Yeah,
Do you put
sarcasm,
the
straw man.
observer? Do you put the observer where he was or where he wasn't? Is that correct or incorrect?
So can you or can you can't steelman us?
Yeah,
you
Ruhiv,
can,
maybe
right?
you should steelman, and then everybody can give a rating from 0 to 10 how good your
Yeah,
steelman
that's
is.
fine. But I'm saying I'm not steelmanning it. Is it correct that you put the observer somewhere where he's not?
This is your steelman? You're asking this question?
Well, I get pulled up as soon as I get one line in, so I want to check where I'm at.
Could you
Dude,
start
we
from the
asked you like 20
beginning?
minutes ago to do it, bro.
Yeah.
How about you start from the beginning? I think I gave a good steel, man. Do you remember what I was saying?
So you
You've
put the observer
given like
somewhere where he's
3
not.
good ones. You've given like 3 good ones. Or 3 or
Is
4.
that a straw man of your position that you put the position put the
No, how
observer
about
where
you
he's
just
not?
give our position of why our
Yeah.
significant, what the measurements, why it's significant, like
Give a
why
fair
it's a problem.
steel man and
Yeah.
then give the criticism. But give a fair steel man first. It's
It's not a
very simple.
criticism. I'm explaining your position. Do you put the observer somewhere where he's not? Is that a straw man or is that correct?
Okay. So you're not starting from the beginning.
Jesus.
You're
All
not
right, there
starting
you
from
go.
the beginning. That's not a good steel man. No. Start from
Ruhiv,
the
it's the
beginning.
only chance of having this be productive, basically. That's the bottom line, you know? So if you can steelman, at least make sure on the same page, then you can give your point, and then it can be the most fruitful, because then everybody can see both sides. All of our time can be most well spent for everybody listening in terms of the sides being able to be fully put forth.
Right. Am I straw manning it to say that?
You're just gonna like ask the same question over and over again, aren't you?
And I don't mean
Well,
sides in a back and forth way. I'm just saying in general, the perspectives, the points being,
Yeah,
just-
Why
I'm
don't you
steel
ask
manning
that
it.
question after you steelman?
Right.
And then
I'm
ask the question.
steel manning it, but as soon as I say what you're actually doing, not a straw man, is it a straw man to say you're putting the observer somewhere where he's not?
Yeah, it's over. It's over.
Okay.
Can I ask you a
It is?
question,
Okay.
Ruhiv?
This
Oh,
this
sure.
is intellectually dishonest.
Oh, shut the
You
fuck
have
up,
to be
Liliana, you stupid
able.
bitch.
You have to be able to
Whoa.
actually
Whoa.
Yo,
steelman.
Rue,
All right. I mean,
doing,
yeah,
dog?
That's a wrap.
You should probably wrap it up, man.
I think that's
Should
good,
can I
Gio.
ask a question?
I don't think these guys. I don't think they can steel man it. Who said that? Someone wants to ask a question.
Can I ask a question? Sorry.
Yeah, if we want to have, yeah, I mean, we're moving on for sure from that. What, unless anyone says otherwise, but yeah, I mean, Ruhiv, that's not cool at all, bro. Anyways, you know,
Can I please ask a question?
yeah, 1 or 2, something else that's on point before whatever you.
Well,
Yeah, go ahead.
yeah, swallow, right? Go.
Yeah,
It's a
it's
great name.
swollen. Yeah.
Go
Yes.
ahead.
Yeah, I was kind of curious about the fact that that star has a negative 15 declination, which puts it about 104 to 105 degrees below Polaris. How was that predicted on flat Earth?
What?
The star that this observation was pointing towards is a negative about 15 or 14 degree declination, which basically means it's 105 odd degrees below Polaris. So I was wondering how this is predicted on flat Earth.
Okay, so this is a totally non-relevant question to what was just presented.
Yeah. I'm not on the topic that Rui was on,
right.
but,
So I think
Yeah.
but I mean, you guys are pointing towards a star, which actually is below,
Same,
like 100.
same explanation that was given the last time you brought it up. So the negative coordinates are just where the star would be when it's out of your field of vision. You guys consider it under a ball. We consider it just out of your field of vision. So it's just represented by a negative coordinate system. And then when it's merged on two hemispheres, like the mapping of that, that's what it comes out to look like. So it's totally fine. That's why this observation is so important, because it shows that the actual interpretation of the coordinate system that's being used is with respect to a flat baseline. That's why all these measurements give a mutually exclusive angle for the flat Earth. And then when you turn on refraction, suddenly, you get the globular prediction that's not manifested in the occultation time. So hopefully that answers your question. If not, that is the answer to the question. So I don't know what else to tell you from there.
Yeah, and the thing is, this can be replicated by anyone, anywhere, right? So it's sort of like, at this point, it's like, let the data flow in. Like, anybody can do it in any scenario, and at least they can present what they get. And then, of course, wherever they do replicate it, once they present that, somebody else can then replicate that to see, to double check and et cetera. So like anyone who presents anything, even that can be replicated, and then that can be, either submitted or presented as well. Because for like folks on the side of saying that the Earth has curvature, coming from, in terms of this, if this were to be done more and more times, and it's always getting with the planar geometry, what position do they have? Yeah.
Well,
What's the
you
cosmic
forget people use
coincidence from?
Stellarium all the time, and their observations match Stellarium.
You're talking about visual optical measurements though, and we're talking about physical ones. And so
He doesn't understand any of that. It's fine. It's fine.
To rectify the differential between an optical measurement and a physical measurement, we can use this method, right? And so
Mountain.
when we use the mountain as a reference marker to physically block a star, all of a sudden it matches a flat baseline.
And all of a sudden, you transformed your location to 50 kilometers away as well.
Right, and you made an optical observation anyway.
Yep.
Sure, but our
Still
point
using
was
your
that
quote-unquote celestial theodolite. Hold on, dude. You're still using a celestial theodolite. That's an optical instrument.
Explain what a celestial theodolite is. Somebody.
But we have to use the optical time that it was occluded, and when
Optical
we do
time?
that, when we optically visually saw it be occluded.
The timing which it was occluded, man. Like, let's not get into like irrelevancy, right? You guys, can you follow along now that we have the proper? You guys know what we're talking about now. So when it gets optically occluded at a specific time, right? So that's what we're saying. So now that we're all on the same page, continue,
Right, because they
PZO.
would argue that it's already physically occluded. It's just not optically occluded, right? Because it's behind the mountain the whole time. That's what they would have to say. But
now we need to find. Now we need to find a perfectly lined up spot.
Hold on. Wait, I don't think he was finished. Go ahead, bro.
Yeah. So, anyways, once you do that and you then go to the reason that you use Stellarium, by the way, right, is Stellarium, it has the useful ability, because it's programmed in to the nautical almanac, to tell you what the nautical almanac says the true position of a star is. We don't care about what visual angles it says it would happen or any of that. All we care about is true position. Remember, because this isn't supposed to be an apparent measurement, it's supposed to be a physical one. because physical objects block physical objects. So when we
Right, you're
do
doing
that,
this optically, of course.
yeah, when we do that, it just happens to line up and match a plane trig prediction.
Yeah,
Now,
And that's the globe.
and that's not being contested, right? Because I mean, we have everyone saying they're not contesting the time the star was occluded. So then the only logically consistent position you have left, if the time wasn't wrong, is that it is a coincidence. That's the only logically consistent position left in your paradigm. So if y'all would just admit that it's a coincidence and say, this is just a coincidence, nothing to see here, folks, move on, we could actually at least somewhat academically and intellectually respect you for that. Maybe not entirely, but more so than what position you're taking right now. Because right now you don't actually have a position other than, nuh-uh, you guys are wrong, Stellarium's right.
Yeah,
which
but
doesn't
Stellarium,
actually
because
have any
people
meaning because
test
we're
their
not.
measurements against Stellarium all the time.
Yeah, but we're not contesting what Stellarium says about what we see.
Yeah, you are.
You are actually.
No, we're saying that where the star physically is where the mountain physically is, which is where the flat Earth baseline prediction using plane trig says it is.
Yeah, and just to reiterate, just for anyone who wants to do this, can even test it beforehand, right? Take any favorite mountain peak that you know about, do a distance from that mountain peak, right? Calculate what the flat Earth prediction would be, which is just plain trig, right?
And refraction.
And then go into Stellarium, put yourself on top of that peak, and there you go. Voila. It'll match the same prediction.
Voila,
Yeah, 'cause
just
you don't
reality.
you
Just
don't have
reality.
to worry about refraction when you've got two different objects and an occlusion between them and a time.
I'm gonna
Okay, so
do
no
this. I
There
can't wait.
being two objects doesn't make refraction disappear.
Oh, well,
Oh,
that's
I guess refraction is cosmically conspiring to match a flat baseline, then, and that's also a coincidence. Cool.
Well, it's sort of
That's
like I
not
think
the
of it.
You just
argument.
added
The
a second
problem is the
variable.
light.
I think of it
The
as like
problem
you're
is the
splitting it
light
in
from
half.
the distant object is able to be refracted anyway, regardless of whether or not there's something in between you and it.
No, I do hear you. I kind of think of it as like splitting it in half in a way because you have that like it's almost like the halfway point at the peak of the mountain. So you have sort of like a more reference than when you know in terms of elevation and distances. So
Yeah, I mean, you can even use a
he
steeper angle though. Let's
But
all
it's the
use a
same
steeper. We could all use a steeper angle though, right? A way
the
steeper
same
angle. To
same optical
Right.
corridor, right? Yeah, that's what I'm gonna say. So it's the refraction can't apply one way and then not the other or whatever.
Well, even if they try to do that and make it apply differently, like on the other side of the mountain, and say that mountain just arbitrarily is the change point, right? Even if they try to do that, they don't realize they're making it worse for themselves because if you add refraction in as a second source of variability, then now you have to say there are two coincidences that are converging to give a plane trig baseline match.
right,
See, in our
right.
version,
Yep.
there's only one thing that's converging as a coincidence to give a plane trig baseline match. But now, since they say we also have to take into account refraction, now you're saying refraction's also happening and it's still matching what we predict. So it's actually worse for you if you say refraction, just so you know.
No, we're just acknowledging that light from a distant object is not suddenly not subject to refraction just because another object is between you and it.
That's
Like
fine.
people
So
making
two coincidences.
people making that argument don't understand our position, right? Because they're trying to equate the angle between the positions of the house and the mountain. It's saying that one is accounted for refraction, one isn't. Not understanding that our argument has nothing to do with the difference of angle projected or not projected from those two positions. The concept of the celestial theodolite is using the mountain as a crosshair, and then the astronomy tool, in this case, Stellarium, as like the timestamp on the bullseye, right? That's how the concept of the celestial theodolite is employed. I even heard somebody says your celestial theodolite is wrong without even understanding. It's a concept we made up for this presentation based on Dr. Mike's observations and measurements, right? To use a theodolite in this way to gauge a star behind a mountain peak is, in fact, the celestial theodolite concept, just so everyone's clear, right? And that's our position. So trying to refute the distances between the 2 points or refraction on or off has no effect on the argument. If you guys manage to defeat that argument, it doesn't affect our position at all, just so you know.
Well, it does. It changes the prediction you're making because you've made the wrong globe prediction.
No, our prediction does not need refraction.
We don't even need a globe prediction. That's up to you guys. Good luck.
Wait, you're saying you don't need to check whether or not the globe prediction actually matches this observation?
Well, you can try. Go ahead. I challenge you guys
So
to do it.
when the globe prediction does match, what do we do now?
What do we do now? I don't know.
No,
We
no,
live
no,
in reality.
no. The way that you get a prediction of like reciprocal nature to refute it is that you have a different star occlude at a different time and have that time equate to the angle that would match the globe prediction, right? You can't just use refraction or just say, hey, that's our prediction now. You have to use the same method, right, to affect the same different angle. So you'd have to use a star to occlude a mountain at a different time, which would then equate to a different angle, right, for a different position of that star. That's what you'd have to do. You can't
That
just
would not
say
match
refraction.
plane trig. It would have to not match plane trig when you then went to the position of the mountaintop and viewed the not viewed
Exactly.
but calculated the true position of the star.
So we have one observation that doesn't disprove the globe.
Two.
Nah, dude, you just didn't listen to the presentation and don't know what you're talking about. I don't know how to tell you in any different way.
What was
Well, the
Okay,
answer
the
is
observation being discussed by the mountain occluding the star doesn't disprove the globe, so we need another observation.
That's just
I
your
think I
opinion,
know.
man.
If I could jump in, I think I know of a way to help Doofus understand this. Using the laser and the sugar water example. So let's let the laser be the star, and it's in a known position. And if it were a flat Earth, we can calculate the position where that laser is and where it's aimed. But when it enters the sugar water, it bends. It refracts. Now, what happens if you stick an occlusion inside the refracted laser beam? It will disappear from the other side of that occlusion.
What?
But
No. A laser beam goes around an occlusion.
No,
is it?
he's saying to occlude the laser beam, dude. What are you talking about?
Right,
I'm
you
saying
can
you
put
stick a
something
piece
that's
of
on a straight line path between the laser and the observer, and you'd still see the laser if the path the laser took is bent.
No,
No,
you're
but
not listening. You're not listening. I'm talking about the refracted laser beam in the sugar water. Stick a tongue depressor or something in there. Will that or will that not block the laser beam where it hits the tongue depressor?
If you block the bent path, then you won't see it. But we're
that's the
talking
point,
That's
about
right?
my
there being a
point.
Right,
straight
that's
That's what
line
your
the
point.
peak
between the
is
star
doing.
and the observer,
That's
which you say is
exactly what
blocked by the mountain,
if
and
you would
therefore
please be
a
quiet.
bent path would go around that mountain.
Go ahead, Dr. Mike.
The tongue depressor in this case is the mountain, and we're sticking it in the refracted beam. It occludes that beam, so the observer sees that beam disappear. That does not reflect the true position of where that beam originated from the laser pointer. The laser pointer is the star. And if you think about that very thoroughly, you'll realize that's why a mountain peak occlude a refracted beam and still indicate to you where that beam originated if you can identify the true location of that laser.
The medium refracting the star is behind the mountain as well. What are you talking about?
Yeah. It seems like you told me I wasn't listening, but you didn't listen to what I said. So if you put the tongue depressor on a straight line path between the laser and the observer, the tongue depressor is between the laser and the observer. If that laser takes a path that is bent, the observer will still see the laser, even though the tongue depressor is in between the laser and the observer.
No, what he's saying is to occlude, to actually block the laser path after it's been refracted. It doesn't matter.
Okay, so the observation that we're looking at, where a star is being occluded by a mountain, you haven't confirmed that the mountain is between the observer and the star.
It got blocked.
Yeah, when I got occluded at a specific time, that's the confirmation of it, Brody.
Yep.
Right, but you did that observation optically and ignored optics in the process.
What? Buddy, it's based off of a time, and we're optically viewing it. What you said is incoherent AF, brother.
Okay, so the light from the star could be refracted more than the light from the mountain, couldn't it?
A death blow this is, I guess, man.
Yo, so
in your paradigm, yeah. But then it would just be a coincidence that it lined up with trig.
So then we have an observation that doesn't refute the globe or a flat Earth.
Wait, can you
we do
concede
though.
that it's just a coincidence? Can you concede that it's just a coincidence that it matches trig?
It doesn't really, because what you're suggesting is that Stellarium can be wrong for the observer's position.
Dude, we just broke down the math. It matches trig.
It doesn't, because you're assuming 60 nautical miles per degree doesn't exist in reality.
Wait. Is 231 the trig prediction to the mountain? Yes.
231 isn't the prediction to the star from the observer's location.
Hold on. Wait. I didn't ask you that. Is 231 the prediction to the mountain with trig?
231 is the prediction to the mountain, but not to the star.
Okay. Is 231 the prediction to the star from the mountain?
It's not the prediction of where the star will be for the observer.
Hold on. From the mountain. If you're on the mountaintop,
The
is
fuck, dude?
231 the prediction to the star?
You have to acknowledge that the star is going to be lower for the observer because the observer is not on the mountain.
On the mountain.
On the mountain.
Is 231 the prediction to the star?
It doesn't matter because the observer's not on the mountain.
So it's a yes,
No,
right?
we're talking about a person being we're taking it to a human, for somebody on the peak of the mountain.
He knows.
What is the angle to the star? You agree that's 231 from the top of the mountain.
It's irrelevant because the observer's not on the mountain. There's nobody standing on the mountain making this observation. There's no reason to point to the star from the mountain peak.
Yeah, you're only saying it's irrelevant because the two numbers match, and that's just a big coincidence in your paradigm. You don't have an explanation.
He doesn't want to admit it.
Yeah,
he doesn't want to admit it.
But it's not just. Hold on. The guy that has the camera has to know where the star is from his position, doesn't he?
231, right? From the mountain.
Not from where he is.
From the mountain, though, right?
Just admit
not
that
from where the person with the camera is. The person with the camera has to see the star in a different place, or else 60 nautical miles per degree doesn't exist.
No, listen, we don't need a distance. We can backwards derive the distance based off of the timing and the angle. That's not a factor in it. Continue on, please.
I'm not talking about any damn distance. I'm saying the star is going to be in a different place for the person with the camera. The camera is not going to see the star in the same place as the mountain.
So I just need you to be honest enough to say 231 is the prediction from the mountain.
Right, but it's irrelevant because the person with the camera is not standing on the mountain.
So when you say yes, but it's irrelevant, what you're saying is yes, that's 231, and yes, the trig angle to the mountain is 231, and those two numbers match, but it's irrelevant and it's a coincidence. Right?
Why is it? Why I don't
the
understand
reason why it's irrelevant is because the observer with the camera isn't going to see the star in the same place. Because again, 60 nautical miles per degree is a thing we observe in reality.
So is it just a coincidence that the two numbers match each other using plain trig?
I mean, it can be. The reason why that angle is 231 from the top of the mountain has nothing to do with the person with the camera. That number is completely irrelevant to the person with the camera.
It's either a big coincidence or it's statistically significant and materially important to our paradigm. So you take one of those two options. The choice is yours.
It can't be significantly. It cannot be statistically significant because the person with the camera won't see the star at 231. It's not possible.
It's just a coincidence, then, right?
I'm glad that you talked over me finishing my answer. You fuck.
Wow, everyone's getting all emotional. I think we should wrap this up, Gio. What do you think?
Damn. Language, gentlemen, please.
Okay,
that's the answer.
Yeah, I was just saying Stellarium. One thing, just that the horizontals are parallel. Is all I was going to say. Is what that
isn't it?
Go ahead.
But they're talking about the observer. Isn't the observer observing the mountaintop?
Right.
Correct? The observer is not observing the star. We're observing the mountaintop. And then the star is going behind it. So that is why angle to the star from the mountaintop is valid, correct? As a layman listening to this, as someone who wants to go duplicate this in her backyard, I'm understanding that as the observer, I want my angle to the mountaintop, and then I'm going to watch that mountaintop occlude a star. So then the angle to the star from that mountaintop should match my trig angle to the top of that mountain. That seems pretty simple and straightforward. Is that correct? Am I understanding this correctly?
No.
Yeah.
Yes.
Yep.
No, you 100% nailed it.
Yeah, for sure.
No, but if you put...
Absolutely am. Correct. No, I'm correct here. I'm not wrong. And we can go duplicate this.
I'm down, Kat. Let's do it.
And also, Kat, right? You can't forget that, their whole contention, right? Because they acknowledge 231 plane trig. They acknowledge 231 for mountaintop. Their whole contention is that, but that's not where you should see the star from your location. It should be different. But the problem is even if it quote unquote should be different, right? Where you should see the star or whatever being at whatever angle you see it, that doesn't change the fact it's being blocked by a mountain. And so you can get a separate conversation going where you say, okay, well, what's the cause as these objects get close to the horizon that, the angles change from what they should be and yada, yada, yada. Like, that's actually a separate topic. It's a separate conversation, what the cause of this optical compression, optical effect, optical refraction might be. But the fact that we have a physical occlusion and anytime you time it, it matches a plane trig prediction of tracing a line, you have no answer for that other than to say it's just a coincidence. And that is not satisfactory.
I've got an answer. It just so happens that, though you've heard of 1 degree per 69 miles, it just so happens that at 31.5 miles, that would raise the apparent angle of the star by 0.456 degrees. So at that particular distance and height difference, it just happens in this case to also match a globe. And so that's the problem here, is it does match both.
So they just need to repeat this at a different elevation with the different metrics.
Wait a second. 0.456 degrees. Isn't that 27 arc minutes?
Could be.
Okay, so 204 plus 27 is 231. I'm pretty sure he had a slide about this in his presentation using the arcsine formula of the distance over the radius to get that same amount of correction. Now, that specifically, that 27 arc minutes is different from the refraction correction prediction, which is about 16 arc minutes, 15 to 16 arc minutes, right?
Yep.
So there's a differential there of about 11 arc minutes. 27 would be the FE prediction and 15 would be the glow prediction. So
wait. To answer Jesse's point, so Jesse, you're saying it matches, right? But did you account for refraction? Because you said you have to. So you would get a different angle, wouldn't you? If you added refraction in.
Because now if you add refraction, then why is the
Then it'd be
occlusion time based on a flat baseline? Because I thought they were supposed to line up using refraction and not the raw measurements.
Yep. If you
he turned off refraction in Stellarium.
Yeah, but you guys just said you have to account for refraction, so why don't you?
Yeah, but he measured it in real life the time it occluded, and according to you, every optical view that we ever take is refraction correct, is accounting for refraction because refraction's happening. So there's no way when we take this timing in real life where refraction is supposedly happening, there's no way it should match the refraction off plane trig versus the round refraction prediction because the two are different. One is a 27 arc minute shift and the other one's a 15 arc minute shift.
But do you see my point? How if Earth is curved, we would get the same results.
No, we wouldn't. One would be 15 and one would be 27.
Are you sure?
I literally just explained it. So anyways.
Yeah, anyway, celestial sphere.
Welcome to the dawning of a truth gold rush, because as more and more data, and this can be done all over the world essentially, and see what all of the net results are, and the fact that the foundational data without adding any refraction is having that planar, that shows a foundation. Because like we were saying before, like even to try to do a globe type thing, if you want to try to say like from the star to the mountain peak and then from the mountain peak to the observer, you want to say there's like 2 different forms of refraction happening there. So even though it is on a globe, they would say, oh, it has to be like perfectly refracting on both of those sides in order to be a perfect coincidence to that it would be a cherry pick, like, and that would be what they would have to say is happening. But if it's and even if they want to say that about one of them, okay, I guess even if I to half give it to them, but then when it's done a second, more and more time everywhere, then to try to claim that there's a perfect refraction happening all over the world, everywhere in 2 different entire corridors to perfectly make it all match the planar geometry is at that point just like beyond a preponderance of evidence that would just get stronger and stronger over time.
Yep.
Yeah, Gio, there's also, this hasn't been brought up in the discussion yet today, I don't think, but there's also an even further extra point that's also has to be a coincidence in their paradigm. So Dr. Mike actually took the angle to the mountain on the globe, right? And it was like uncorrected was like 217. Okay. Instead of applying the terrestrial correction formula to it, he applied the celestial correction formula because they're actually different, right? They use a different
way more refraction.
Right. And when he applied the celestial refraction formula to the mountain, the angle to the mountain matched plane trig as well.
Yep.
No, I just checked my
Crazy,
math,
right?
and I was correct.
So
hold on, Gio, what do you think about that? Have you heard of that before, dude? Maybe he might have stepped away, but that's just any. Oh, you there, Gio?
Well, yeah, no, I am here, but I did get distracted for the last second. My bad, dude. I'm sorry. If you wouldn't mind repeating it, or I'll go back and listen real quick. Yeah, sorry.
Yeah,
repeat it.
So I said there was another coincidence that wasn't actually brought up here yet today, from what I can tell. Dr. Mike also did another thing where he took the globe prediction for the angle uncorrected to the mountain, which was like 217, and he applied the celestial, not the terrestrial, but the celestial refraction correction formula to it, which is a bigger
raise the angle.
And it brought the mountain from 217 to 231, which is the plane trig prediction.
Yep.
So when
coincidentally,
when he applied celestial refraction to the terrestrial object, it became a plane trig measurement. Also.
Wow. Yeah, there it is.
Is that right, Dr. Mike?
Yeah.
That's right, but I would like to point out that when I presented that, I said that's just one data point. It's possible one data point is just a coincidence, and that's what began me on the path of realizing that refraction is the problem. It's everybody and his brother is making these refraction corrections, and what I began observing is the refraction corrections make the difference between flat Earth and globe Earth. And so that's when I set about a way to completely eliminate refraction from the equation.
Nice.
That's how they determined what the quote unquote correct amount of refraction is all. Yeah, because they didn't know what refraction was. All they did was assume that it's happening, and that must be what's causing these differentials we're seeing. Well, how much of a differential are we seeing? Well, we know it's a globe, so if we just calculate what it should be versus what we're seeing, there's your refraction, here's your standard formula. That's what they did. So they actually worked backwards to get to refraction.
It's pretty crazy,
extrapolating
actually.
from the celestial sphere, exactly, to a presumed globular surface. Phew, yeah.
Right,
Well
which
said.
is our argument the whole time, which is definitely our position.
So it's just a reification to begin with.
And Dr. Mike, when did you become a flat earther?
I think it was right about January 27th when I first saw that the star matched the flat Earth angle. That was my first step. Probably the second step is when I measured Blodgett Peak and the same thing happened. It's like
it's too coincidental, right?
Yeah, to a 3 sigma level of confidence, I'm a flat earther.
Woo! It's 99.7%, baby.
The way I heard it was you gave us awesome tools from still a globular position, but then when you used the tools that you gave us, you convinced yourself accidentally. That's just how I heard it.
So that's a good interpretation because, as you know, when I joined your group, I was convinced yours was the globe, but I felt like you were all kindred spirits. You realized we've been lied to about a lot of things, and you were digging deep to find the truth, and you were using good methods. And so my original presentation was about the luminiferous ether because I'd written a book on that. And anybody who cares about that can find that on GitHub under Dr. Mike Heffron. It gives the presentations, it gives software, but as I was listening to the debates you were having with our Globe Earth friends, I realized they were using a lot of dirty tricks, and that you guys needed better tools like the null hypothesis.
Absolutely.
Yeah, and so in the process of showing you how to use the null hypothesis to determine whether the Earth is a globe or flat, that's when I accidentally discovered it's flat, and you made a convert of me.
I love it. I love that story. I'm gonna keep telling it my way though.
That's okay. I won't.
We
I
are
won't
so
refute. I
happy to
won't
have you.
refute your way. It's a good interpretation.
I love to hear your
So-
more detailed checks.
So again, everyone should do this. Everyone should repeat this. Go find a mountain peak. Calculate your plane trig, right? The distance between you and the mountain peak. Get the elevation and the distance between you and that mountain. Boom, you got your angle. Put yourself on top of that mountain using Stellarium or whatever astronomical tool you want to use. See if the angle matches. And then if you really want to get, really want to get deep, get yourself a Theodolite and do that angle without any refraction correction. See if it matches.
Dude, he claimed that the elevation angle he measured to the star from his house doesn't match Stellarium.
Yeah, because it's taking into globe curvature of the ground, bro. That's the point of him cutting that out.
Because Stellarium uses a celestial sphere, 1 degree every 69 miles.
It's the graticule, bro. Were you here for that earlier?
No, he doesn't
Really
understand
simple.
points.
I mean, I don't know why you're saying that Stellarium is wrong.
I thought he measured the mountain, though.
No one is saying that Stellarium's wrong. When you
Yes,
say that,
you
you're
would
not giving
be.
context.
You would be
No.
saying that the elevation angle measured from his house to the mountain is not 2 degrees and 19 minutes. That is 2 degrees and 30 minutes.
Well, actually, if you listened this entire time, we said the angle measured to the mountain optically doesn't matter. All that matters is the time.
Why not?
Because, dude, I've went through it like 6 times, if not
Yeah.
more. You should probably just go replay.
All right, then take a back seat. If you don't want to go over it again,
No, he has no argument. He hasn't heard anything. He hasn't.
Yeah,
I
the
wouldn't address
argument
him
is,
at all, Pedro,
yep,
to be
listen
honest.
close. Ready? The elevation angle of the star from his house is going to be 2 degrees and 19 minutes on Stellarium. Are you saying that
Why?
Stellarium is wrong?
Hold on,
Yes
wait.
or no?
Why? Do you know why it's
nothing to
that?
do with it.
Because he's also claiming that the elevation angle of the mountain from his house is 2 degrees and 30 minutes.
Hold
And
on,
the
I want
star
you to
got
answer why,
occluded-
though.
And the star got occluded by the mountain.
I want you to answer
So
why
is
it's 2
Stellarium
degrees,
wrong,
19
or
minutes.
is Dr. Mike wrong?
Hold on, bro. Why is it 2 degrees,
You don't
19
even know what I'm
minutes?
trying to tell you. You're not paying attention. Do you want me to repeat it for you?
He just wants to
I
talk.
know.
He's trying to
Yeah,
respond.
yeah.
Hold on. Just let him respond. At least. Beasticles. Yes.
Okay. I just want to. You know why it's 2 degrees, 19 arc minutes from Stellarium from his house to the mountain peak?
It's actually the height of the star is actually 2 degrees,
Not the star.
5 minutes, and then they invoke refraction because of
Not
how
the
close
star.
to the horizon.
The mountain peak. The mountain peak. Do
The
you know
mountain
why?
peak would have to be the same height that Stellarium predicts for the star at that time.
No, not the star. The mountain peak from his house to the mountain. So from the mountain peak to his house, 2 degrees, 19 arc
Right.
minutes on Stellarium. Do you know why?
Can you answer my question first?
What's your question?
If he's taking an elevation angle from his house to the star, and Stellarium is accurate for literally everyone else who ever uses it, then his measurement would have shown 2 degrees and 19 minutes. Are you
Okay.
saying Stellarium is wrong?
Do you know why it's off by 27 arc minutes? We went over that. Were you paying attention?
No. His claim would be that it's off by 12 arc minutes.
Yeah, but is that optically or physically?
So now optical measurements don't work. So what are we even talking about?
No, the whole point is that when you talk about refraction, that's an optical effect purely. And we're talking about a physical obstruction and a way to measure that.
Right, trig, not a measurement.
But blocking a star, taking the time, comparing trig to the different location and seeing that they match. So the only option you have left is that's a coincidence.
I don't understand. Like, did he actually use an optical instrument to measure the elevation angle of the mountain or not?
Did you just hear what I said?
Listen to
That's
my
just a
question, since now you're not
coincidence.
answering it.
Yes.
Ready?
Yeah, you're just
You're
trolling.
saying
Yes,
yes.
he did. Yes,
So
he
then the
did. From
elevation
his
angle
house.
that he measured would have
Yes.
had to have been 2 degrees and 19 minutes.
But
No,
hold
that's
on. Number
Oh,
one,
if you're
that's something
saying it
you
was 2
measured.
degrees and 30 minutes, then Stellarium is wrong.
Hold on a second. You are skipping completely over our point, and you're arguing against a man made of straw.
I don't
right
think
now.
you have a point. I think you're a liar.
Hey, well, hold on one second, dog. I'm just going to go ahead and mute you there. Bezio, go ahead and correct this man. And then Globe, what's his Globe Pop-Tart? Go ahead and get your final thought off, and then we're just going to move on from that or whatever. So go ahead, Pizio.
Yeah, so the whole point is that he did take a physical measurement, right, just for good measure, but it doesn't actually matter what his measurement of the angle was, because as he said, throughout different times of day, etc., that angle can vary. There's variability in that angle. But what's important is that he got an accurate time for when the mountain occluded the star. And based on that time, if viewing the star from the mountain at that time, it matched the same angle as the plane trig angle to the mountain from his house. So that one could then, using a flat baseline, trace a truly straight line from the star to the mountain to his house using that same time. In your paradigm, you have to either completely ignore that and just not address it at all and keep asking questions about, well, what angle did his theodolite measure? Or you just have to say, that's just a coincidence and it's irrelevant. That is what happened, but who cares? It doesn't actually mean anything. It's just a coincidence. That's the only
right.
logically consistent position that you can take.
Let's see what he says. You're free now.
Honestly, yeah, this is what I have to say. Are you ready? I'm looking forward to you transforming a celestial sphere to a celestial plane. I can't wait to see what you guys do.
What?
Yeah, so a non-address
Nice. Yeah, your concessions noted. Another one.
I have a question.
Yeah, thanks.
Nah. Or go ahead, Jesse. What is it?
What was the name of the star that was timed dipping behind the other mountain?
Ooh, good question.
Ooh,
If Mike's
can't
not there,
remember
if Mike's not here, I'll look it up on the
Mike's still here.
PDF. I'm pretty sure I can find it.
I'm still here, and I don't think I mentioned them, but it was a bunch of stars. So let me see if I can find the list here. Okay. Oops, wrong one. So on Blodgett Peak, it was HD 205605, FT1 Aquarii, LP Aquarii, HD 216718, HD 216953, HD 217877, and 96 Aquarii.
And what was the times that those clipped the mountain?
These were all on February 1st. That was the last good viewing day I had. And the times in Mountain Standard Time were 1824.44, 1912.56, 1930.02, 1943.27, 1946.02, 1952.51, and 200710.
Thank you.
I didn't know you did that many stars, Dr. Mike. That's awesome.
And actually, that's only one sheet. I've been recording them on various sheets, and that was the one I could lay my hands on first. And then for the presentation, what I did is I just gave you the average and the variance.
Gotcha.
Write that down. Write that down.
I'll have to just go back, and I couldn't write it down that fast, but I'll go back and get the recording and then write it down, and I'll check it out on Stellarium. But since the only peak that we've been given information in advance for is Pike's Peak, it is true that on a globe of a 3959 radius, the elevation angle to a star would be lifted 0.4562 degrees if you got 31.5 miles closer to it. That is a fact. And the Stellarium predicted angle without refraction at your house, it was 2 degrees and 5.5 minutes. And if you add that 5.5 minutes to the 0.45621 whatever degrees of being closer, it is 33 minutes, 2 degrees and 33 minutes. So it actually would work out that particular case would work out exactly like that on a globe as well.
Actually, Jesse, the math you did is the math for using the differential of the chord to the line, and that correction would actually match anywhere on Earth. The problem is that that 0.456 degrees is 27 arc minutes, which is our whole point. That's different than what your paradigm claims would happen on a globe, because your paradigm on a globe claims it would go from 205 to 221, which is about a 16 arc minute correction. And for us, it goes from 205 to plus 27 arc minutes. So 16 versus 27, there's an 11 arc minute difference there, which is well above his margin of error for the timing differential.
But my point is it not true that on a sphere of 3969 radius, that approaching a star 31.5 miles closer would raise it 0.45652 degrees? Is that true? Just geometrically, if you had a sphere, any sphere, 3959, and you moved 31.5 miles along the surface towards the star, it would raise that much. Is that right?
That would be the angle you'd see it at from the mountain compared to where his point of view was. We're not contending that point, but the problem is we are seeing it blocked by the mountain where he was at the angle that it should be seen from the mountain.
But
so, like, you're talking about something different right now. Like what you're saying isn't actually solving any problems.
But it shows that this particular data point works perfectly on a globe also, because if you have a sphere of a known radius, you can calculate the angle change, the apparent angle change to an object of insanely great distance by knowing how far along that surface you move. And if you take a 3959 radius sphere and you move 31.5 miles along that surface towards a point at virtually infinite distance, that point will geometrically appear to rise by 0.45. It will.
Yeah, we know. That was part of his presentation. He explained that in the presentation. That's why he did the arc sine of distance over radius calculation. But the point is that wouldn't cause it to be physically occluded by the mountain at the same angle predicted by plane trig to the mountain. It should be different by about, 12 arc seconds or 12 arc minutes, and it wasn't. So that 12 arc minute differential should be manifested through something that doesn't match plane trig. It should be a different occlusion time, or at the very least, even if it did coincidentally happen to be the same occlusion time, the angle from his house shouldn't match the angle to the star from the mountain when it was occluded.
Well, the problem is you're assuming a flat Earth to prove a flat Earth. Your argument only works if all plumbs are parallel. But if the plumb on the mountain is not parallel to the plumb at the point that the timing was taken, then your measurements are off.
We're not
No.
assuming it to prove it. We're saying what does it predict? Does it match? Like you have to have a prediction in order to have anything meaningful in the first place, brother.
Yeah, and this is actually argued in the form of a null hypothesis. So we're actually assuming that the Earth isn't flat for this, or you could like flip it either way. But anyway, yeah, this is just based off of the raw calculations to it. So that's the distinction here. We're not assuming anything, right? So this is just where
Right. I
the
want to ask a
occlusion
question
time is
real
taking
quick.
us.
You're
Sorry,
presuming
Alan.
a flat Earth when your elevation angle to the Pikes Peak is 2 degrees and 30 minutes.
That's
Okay, I
what
want
we
to ask
predict,
Claire.
and we see if it works, right? So that's how you do science. Oh, well, the mountain, including the star, said it did, though.
He doesn't understand.
Weird.
you're not helping anyone. Dude. Stop
58,
addressing him.
50,
It's
you got a
crazy.
question,
So
bro?
weird
Yeah,
how
I
that mountain
want
blocked that star, bro. It's so
I want
weird
to
how
ask
that
you.
mountain blocked that
Can we
star.
let
Pop-Tart.
50 ask his question, Globy?
Yeah, Pop-Tart. Let me ask you a question real quick. So, am I correct whenever I'm stating that Dr. Mike said that the elevation angle was changing throughout the day to the star? Is that right? He said that.
No,
No, to the
Well, he
peak of
said
the
it. He said it
mountain.
the
would.
mountain.
Yeah, to the peak of the mountain. Yeah, sorry. my
Okay.
bad.
Okay. So if it's changing constantly, couldn't you just pick a time where it matches?
No.
No, there's only one time when the mountain blocks the star.
Right. That's the point of using the star.
Not just about measuring the mountain, bro. It's about measuring the mountain and star lined up with one another at one specific second.
Beauty of
Picking ones. I think to further this, you would need us to pick.
Observing and seeing which stars that peak occludes, and record the time like I did for each star that peak occludes, and then once you have the date and time and get it to the nearest second at least of the occlusions, go look those up in your favorite astronomy tool, and all the astronomy tool, you're on that mountain peak you just saw occlude star, and ask it what's the elevation of that uncorrected elevation of that star, and just record all those uncorrected elevations you find based on your own timing, and then compare that to what a flat Earth prediction is for what the elevation angle should be versus a globe Earth prediction of what the elevation of that star should be.
Very well. Thank you, Dr. Mike.
Thank you, good sir.
You got dogs to go rescue.
And
It's
make
late.
sure to download this stream and get this doctor some bodyguards, huh?
I think you'd be
I've
all
got
right, man.
about 20 bodyguards at the moment.
Yeah, and he's probably strapped, so be careful there. I'm not saying one way or the other.
All right, cool. I'm going to go
Locked
ahead
and
and
loaded.
close this out. I'll be back in a minute, boys.
Nice, Dr. Mike.
Oh, actually, before I close out, while everyone's here, let me just go ahead and promo tomorrow night. So tomorrow night, I'll be giving a Prezi on reference frames and the physical meaning of mathematics, kind of going over the history of classical physics and how a reference frame is defined, and then how that transitioned into relativity theory after they took some certain measurements in 1887 that we may or may all not be familiar with around here. So we'll get to that tomorrow at 10 p.m. So if you guys are interested in that, that'll be tomorrow. All right, and then Globebusters will, of course, be on Sunday. And then Shane will be presenting on Eratosthenes on Tuesday at 8 p.m. All right, lads and ladettes, see you later. See you tomorrow.